Baik Bapak Ibu hadirin yang berbahagia, di kesempatan kali ini langsung saja kita akan lanjutkan untuk seminar sesi kedua bersama dengan seorang profesor yang kita hadirkan jauh-jauh, kita terbangkan ke kota Yogyakarta. Ya, pada kesempatan kali ini kita hadirkan profesor dari IPB University, beri tepuk tangan paling hangat untuk Profesor Dedi Jusadi. Kami persilakan kepada Profesor Dedi Jusadi. Ya, annyeonghaseyo, sarang yo. Terima kasih Prof.
Baik Bapak dan Ibu yang saya hormati, Assalamualaikum warahmatullahi wabarakatuh. Saya Dedi, tadi disampaikan. Saya diminta untuk menjadi moderator, 4 presenter. Untuk itu saya panggil yang pertama Bapak ya, Dr. John Hargreaves, Chief Editor Was Magazine. Second, Dr. Mian Riaz from Texas A&M University. Halo. Third, Prof. Agus Suprayudi. And last is Robert Blanc from Konabe. Oh, virtual. Oke. Mungkin yang ketiga tadi virtual ini presentasinya. Baik, please sit down. Baiklah Bapak dan Ibu yang saya hormati, kita mulai. Yang pertama Dr. John Hargreaves ya, yang akan membawakan presentasi dengan judul What is the carrying capacity of your farm? How much you can produce? Please.
Good afternoon. Selamat pagi. This is my second time to come to Yogyakarta. I was here 35 years ago as a much younger man. Thank you. I visited your beautiful city, climbed Mount Merapi, visited Borobudur, and while I was in Indonesia, visited many fish and shrimp farms because I was already interested in aquaculture at that time. So today I want to talk to you about carrying capacity and want to explain a little bit about it and then really how you can manage carrying capacity to maximize that capacity that you have to be more productive and profitable. Very good. Okay, so this is a brief overview of the presentation. I'm going to start with some basic descriptions of what carrying capacity is. And then I'm going to talk about some of the factors that control what I call loading limits. And loading, what I mean by loading, that's the feed that you're putting in. How much feed can you add to a pond on any given day? And that changes. And then I'm going to go through some examples of some different production systems, mostly intensive shrimp ponds, to show you some examples of real-world accomplishments, what can be obtained. And then the last part of the talk is just about managing production capacity. So to start off, you need to make a decision about your stocking density. okay? And ultimately that will lead to your carrying capacity, and there are a number of factors that affect that, the kind of infrastructure you have available. And I'm going to talk a little bit about pond size, because I think that's a big factor. Smaller ponds tend to have a higher carrying capacity than larger ponds. And each pond has a different carrying capacity that depends on the characteristics of the water and the soil, for those of you who have soil-based ponds. Then there's variation by season. In your case, rainy season, dry season, cool season, warm season, that'll affect carrying capacity. And ponds have a history of performance. Some keep doing well, others not so good. Maybe because of the soil, maybe because of where it is in the system with respect to water sources. And then the experience that you have as producers. If you're more skilled, you can obtain a higher carrying capacity. So all of these go into that decision of how many shrimp should I stock into a pond. All right, so this is an important slide in the presentation because this basically defines what carrying capacity is. And I'll just read this out. This is the maximum biomass that can be sustained in a production unit, okay? And another way to look at this, it's not just the biomass, but it's the feeding rate that you're adding to the pond that can support that biomass, okay? So in that respect, it can be defined as the capacity of a production system, in your case a pond, to assimilate organic matter and metabolic wastes that are produced as a result of feeding. Okay, another definition, maximum production possible while maintaining water quality within the tolerance limits of the cultured animals. Now, shrimp are, relatively speaking, more sensitive to poor water quality than, say, a fish like tilapia, okay? So those tolerance limits need to be taken into account. So this is a graphical representation of carrying capacity. This is the number, so this is that maximum number. Now, the idea with the carrying capacity is that you have some kind of limit, in this case defined as environmental resistance, that imposes that limit on the carrying capacity, okay? And each system, again, is unique. So this is another way to conceive of carrying capacity. And down here at the bottom, this is your pressure indicator. So this would be stocking density or feeding rate. And then this is the quality of the environment. So you're starting with a high quality of environment, and then as you increase stocking density, increase feeding rate, the quality goes down. It reaches some threshold, and then you have a pretty rapid change to a poorer condition. You can conceive of dissolved oxygen as one indicator of that poor water quality, but there are others. Okay, so this is just a kind of a graphical depiction of that. So the carrying capacity in most production systems, pond production systems, is limited by the oxygen supply, all right? And oxygen supply in shrimp ponds and fish ponds is pretty complex, and it's related to factors that add oxygen to the water, in this case photosynthesis by algae, diffusion from the atmosphere into the water, and then if you have paddle wheel aerators, those aerators are adding oxygen as well. And then you have these things that are removing oxygen from the water. You have the respiration by the algae and the bacteria in the water column. You have the respiration of the shrimp crop, they're consuming oxygen, and then the bottom sediment is consuming oxygen as well. So it's a pretty complex matter, and it varies through time and through space. And the key challenge to you as shrimp growers is to get oxygen from the surface or from the water column down to the bottom, because most of the time the shrimp are going to be down there. You can have good oxygen in the water column, but down where the shrimp are, the oxygen is very low. So this is a major engineering challenge associated with shrimp farming. So the other important point about carrying capacity is that you can change it, okay? You can increase the carrying capacity through technology. And I've kind of depicted that here, and this is sort of a generalized scheme. And I want you to think about some of the more traditional tambak that you have here for growing shrimp, very extensive kinds of systems, often associated with mangroves, and those are not really fed very much. So you're relying on natural productivity. You can achieve, I don't know, somewhere between 300 and 500 kilos per hectare as a carrying capacity in systems like that. But when you start feeding, you can raise the carrying capacity because now you're adding nutrition from outside the pond. And then later you can start adding, by managing water quality through adding aerators, and you can increase your carrying capacity that way. Then you can start doing water exchange and running systems as flow through. And you can see you're increasing the carrying capacity as you go along this system. You can't see it because the text is down below the couch, but what that says is that as you move along that pathway, you're adding more and more inputs from outside the pond. At low intensity, more extensive systems, you're relying on nutrition and water quality management from within the pond. But as you move along, you're adding more and more inputs from outside the pond. Okay, now I know I have up here a graphic that shows you about fish. It doesn't say anything about shrimp. But the numbers that I have here, particularly the numbers I have for tilapia, are more or less what you're going to find in shrimp production systems as well. So what we have on this side are various combinations of inputs, okay? And over here, these are the production levels that you would expect for a given level of inputs. And then over here, this is the important column here, because what that does is it shows you the limiting factor. And what I want to emphasize and point out here is at these sort of intermediate levels, dissolved oxygen is the main factor that limits productivity, will limit your carrying capacity. So I want to focus on dissolved oxygen because it's an extremely important variable. As you get into very high intensity, more than 10 tons per hectare, other metabolites, particularly the accumulation of waste organic matter on the pond bottom, becomes a limiting factor. And so a lot of farms are operating pretty much in this level where you have this transition between oxygen limitation over to metabolite limitation. So as I said, one of the ways to conceive of carrying capacity is with respect to loading limits, the amount of feed that you can put into a pond any day. And ideally, you want to put that in every day. So ponds themselves provide a number of natural processes. Some of them are physical, some of them are chemical, some of them are biological, that help rid the waste of the nutrients that you're adding. And those rates vary over space and time. Now, if you operate within the limits of that pond to assimilate those wastes, there's no cost to you as a producer. But as you exceed those limits, there's a cost, and typically that cost is associated with the addition of aeration equipment. And normally, again, this is down here at the bottom, there's really a low level of management control over some of the basic parameters of production, specifically dissolved oxygen and temperature and off flavor. So here I have a list of factors that control these loading limits. Okay, and again, this is indicative of the kind of complexity that you're dealing with. Temperature is the most important water quality variable. Okay, so that's going to affect the pond metabolism and water quality. This is the critical one. So there are two parts of this oxygen issue. One is to supply a certain quantity of oxygen, kilograms per hour, kilograms per day. And then you also want to maintain some minimum concentration, and I'll get into that in a minute. I mentioned this before about these water quality tolerance limits, okay, and each species is different. Shrimp tend to be a little bit more sensitive than other species. And then you have these natural processes that lead to the assimilation of organic matter that's added to the pond, and various processes that remove nutrients. So you have this interaction between the aquatic environment, the pond environment, the biology of the animal, and the climate where you are, okay? So obviously that makes for a pretty complex situation. So here's some numbers that you might want to write down or look at here. So these are systems that without aeration, you can achieve a maximum feeding rate up to about 50 kilograms per hectare per day, and really not have to worry about dissolved oxygen depletion. Now, emergency aeration would mean aerating at night or aerating intermittently. You can get up to 100, 125 kilos per hectare per day. If you're aerating continuously, 150 to 200 kilograms per hectare per day. And then if you operate with water exchange, 200 to 300. And in biofloc systems, it can be up more than 300, depending on how much aeration that you add. I would also like to say here that this number, this 200 to 300 kilograms per hectare per day, is also the limit of what algae can assimilate. Okay, once you move beyond that limit, the bacteria in the system become much more important in terms of regulating water quality. The other thing about these feeding rate limits is that that's the number that I gave you there in that previous chart. You can operate in this zone, okay, I call it the yellow zone, where you go above those feeding rates, but you're beginning to take risks because what happens is the water quality begins to become unstable. And then when you get up here in the red zone where you're at 150% of those values in the previous table, then you're really asking for trouble, okay? So you can operate in here, but you also have to be willing to accept the risks of potential water quality problems. All right, so this graphic basically shows the consequences of having an environment that's very stressful, okay? And here I've listed low dissolved oxygen concentration as a stress factor, but there are many others. So you can basically put one of these stress factors in here, and some of these occur with increasing frequency in intensive systems. So there are consequences for survival. So basically, if you have a stressful environment, it affects the ability of the shrimp to fight off diseases, and that will affect survival, which, again, this is below here. It says reduced yield, and then the other one below says reduced profitability. Stress also reduces the appetite of the animal. It doesn't want to eat as much, and so that's going to affect growth rate. And then that's going to reduce yield and profitability. And then of the feed that it does consume, the digestibility is not very efficient. And so that increases the feed conversion, and that addresses profitability directly. So stress has effect on survival, growth rate, and feed conversion. And these are obviously the important factors related to productivity. So maintaining good conditions with respect to oxygen are really important. I think there's increasingly a recognition among shrimp farmers in Asia that if you maintain conditions, DO conditions in the pond between 5 and 6 milligrams per liter, that's ideal. The way to interpret this graphic, so here's dissolved oxygen concentration, and this is the percent of the maximum respiratory rate. So if you're at 6 milligrams per liter, that's about your maximum respiratory rate. That indicates your maximum growth potential, okay? It's like a fire burning in a box, and you have just a big hole for air to come in or a tiny hole for air to come in. You want a big hole. You want that fire to burn hot. That's your maximum growth potential for the shrimp. Now, oftentimes in green water ponds, you have dissolved oxygen that looks like this. It's fluctuating up and down day by, during the day it's going up, and during the night it's going down. So often you get down to these stressful levels, and you're reducing your growth potential. So it's really important to try to maintain the concentration near these optimum levels to have very efficient growth. All right, so what I want to do now is to talk about some carrying capacity and some shrimp production systems. Now, I always like this graphic. This comes from Robbins McIntosh of CP in Thailand, And he talks about different production systems in terms of time, in terms of the generations. You know, we started off, and particularly in Latin America, with these large ponds, 10 hectares, up to 30 hectares. And then we moved into these second generation ponds of 1 to 2 hectares. And these numbers here are basically what the carrying capacity is, okay? So in these large ponds, it's around 300 to 500 kilograms per hectare, most often. Sometimes you can get a couple tons out of it. And in these 1 to 2 hectare ponds with some aeration, you can get maybe 10 tons per hectare, okay, per crop. Most of the ponds nowadays, especially here in Asia, are these Generation 3, Generation 4 ponds where they're smaller, half to 1 hectare, or in case of Generation 4, less than a half a hectare. These have liners. These are typically earthen. You can get 10 to 20 tons per hectare. That's your carrying capacity again. And up to 40 tons per hectare in these Generation 4 systems. I'm not going to talk too much about Generation 5, the recirculating systems, but that's coming in the future, and there'll be a certain amount of shrimp produced in those systems. So most of what I want to talk about this afternoon are these Generation 3, Generation 4 systems. And here you have the capacity to remove waste solids from the pond bottom. Okay, so this is also an interesting graphic. I mentioned this in the beginning of my talk, that you can have a higher capacity, carrying capacity, if you have smaller production units, okay? So for ponds that are a half to 1 hectare, you can get around 6 to 7 tons per hectare per crop, okay? If you go down less than a half hectare, you can get 15 to 20, all right? If you get less than, say, between 0.1 and 0.4, 1,000 to 4,000 square meters, you can get 30 to 50 tons per hectare per crop. Okay, that's sort of the maximum levels. And again, down below, these are ponds that are 200 to 1,000 square meters, and you get 60 to 80 tons per crop. Okay, so why is that? Basically, you have much more control, not only of the crop, over feeding, management of water quality, management of disease, harvesting, managing bird predation, all of those kinds of things. So smaller units, higher carrying capacities. That's just the basic trend. All right, I want to talk about a couple production options. One of them are these lined biofloc ponds. Now, biofloc was very popular 10 or 15 years ago. I don't think it's as popular now among shrimp farmers, but we have some lessons that we've learned from growing them. They're typically small ponds, high stocking densities, up to 150, very high aeration rates that you need because you have to have a lot of turbulence in the water to keep those solids in suspension. And it also keeps the water quality pretty stable, okay? Sludge removal by siphoning, you keep the solids at less than 15 milliliters per liter in the Imhoff cones. You can use grain pellets. You're basically manipulating the carbon to nitrogen ratio of the water, and you can get 20 to 25 tons per hectare per crop, okay? So again, that's your carrying capacity, 20, 25 tons per hectare per crop. Or 2 or 2.5 tons per 1,000 square meters if you think about it that way. So I believe this system was actually developed here in Indonesia. It's a semi-biofloc system, which means it's not a full-blown biofloc systems. And by that I mean the amount of solids that were allowed to develop in the system were much less, usually around 5 milliliters per liter. So it's kind of a hybrid system. Where you have a mixture of algae and bacteria. And remember, like I said, once you get past 200, 300 kilograms per hectare per day feeding rate, the bacteria become much more important. And this is one of those. That's why bacteria are dominated. Now, this is important, too, that, you know, you have to prepare ponds before stocking, okay? And so there was a protocol developed that involved mineral amendments and involved probiotic additions just to get the pond going. Central drain to remove solids. Aerator positioning is really important to keep those solids moving towards the center. You had feed coated with immunostimulants and that sort of thing. Stocking at 80 to 100 per square meter. and you can get 15 to 20 tons. So not quite as much as what I showed you in the previous slide, which was 20 to 25 tons, but 15 to 20 tons per hectare. I think that's a pretty reasonable target for most intensive shrimp farmers in Indonesia for ponds between half hectare and 1 hectare. Okay, so how much aeration should you add to ponds? Well, this is a guideline based on kind of a rule of thumb that 1 horsepower of paddle wheel aeration can support about a half ton of shrimp. And again, that's not based on any kind of science or anything. That's based on experience that many of you have had, okay, in terms of the amount of aeration that you need to support a shrimp crop. So based on that, what I did is just develop this chart using different ranges of stocking density and how much aeration that you would need, and then the kind of yields that you could expect from a setting like that. So if you're stocking, say, at 100 per square meter, you want to have about 24 to 32 horsepower per hectare. So for a half hectare pond, that would mean somewhere between 6 and 8 2 horsepower paddle wheels. Okay, that would be equivalent to that. And from that, you should expect 14 to 16 tons per hectare. I think easy 15 tons per hectare. If you're good, if you're skilled, I think you can probably get up to 20. Okay, what I wanted to show you here is just a chart. This was based on basically surveys of producers in these countries. This was done by Claude Boyd from Auburn University. For ponds in different countries, these are like the average stocking rates. And what I wanted you to focus on was basically the aeration requirement. This goes back to the previous slide. So you have aeration rates ranging from 10 to 40. Unfortunately, they didn't have the data from Indonesia, which I suppose would be of most of interest to you, but you can see what countries like Vietnam and Thailand are doing and the kinds of yields that are actually obtained on average from producers who use that kind of scenario with not just the aeration rate, but the number of hours that they're operating those aerators. Okay. This is an important point I wanted to make here about feed oxygen demand. And basically the idea is that when you add a kilo of feed, there's a certain oxygen requirement to break down that feed. Now, part of that oxygen requirement is related to respiration by the shrimp crop. And that is about, so this feed oxygen demand ranges from about 1 to 1.1 kilos of oxygen per kilo of feed. It depends on the feed conversion, but that's roughly what it is. And about a quarter of that requirement is related just to respiration by the shrimp crop, okay? The other half of it, okay, is related to oxidation of the organic matter that's on the pond bottom, okay, the fecal waste that result from that production. So that's the part I wanted to focus on here. Because if you can remove that from the pond, then you can spare the oxygen that you're adding from the aerators and give it to the shrimp instead. So that's why operation of these central drains, these shrimp toilets to remove organic matter is so important, because it reduces basically 50% of the feed oxygen demand. All right, so that's a good thing. You want to do that. All right, another example I wanted to provide for you is from Vietnam. Vietnam's an interesting story because they grow shrimp in many different ways, many different production intensities, similar to here in Indonesia. And you can see what they get from the intensive ponds. Again, this is the carrying capacity, about 5 to 10 tons per hectare for intensive, and then the super intensive, 20 to 40 tons per hectare, okay? So, again, all of these are sort of guidelines for you on carrying capacity. Here's another system from Thailand. It's a kind of a recirculating system where you have a production pond and then a treatment pond here. Stocked at 250 per square meter, you can get 25 tons per hectare, or 10 tons in a 0.4 hectare pond, with a maximum feeding rate of 330 kilos per day. Now, in a 0.4 hectare pond, say roughly, that's more than 600 kilos per hectare per day of feeding rate. So you definitely have to remove solids in order to be able to feed at that high level. All right, so for the remainder of this talk, what I want to do now is to talk about how to manage that production capacity. So if you have a certain feeding rate that you can sustain day after day after day, or a certain stocking density that allows you to achieve these high production levels, how do you manage that? How do you manage that to improve profitability? So there are a number of ways, there are a number of approaches to do that. One of them I think that has emerged that's really interesting is feeding frequency, okay? So it used to be, I work a lot with the shrimp farmers in Ecuador, and they have big ponds, 10-hectare ponds. So, you know, normally they're feeding only once or twice a day. They send a guy out in a canoe and he shovels feed into the water. So all the shrimp have to eat that feed once or twice a day. It's just like you, like us, as humans, we only eat 3 times a day. What shrimp like to do is to eat often, and basically always, okay? And so now we're feeding not just once or twice a day, but every 10 minutes with these automatic feeders that are either programmed with timers, or they use hydrophones, acoustic sensors to listen to the shrimp eating, and there's a feedback mechanism. And that's what's depicted down here is a graphic where you're feeding almost always based on that feedback mechanism. And not only does that improve growth rate and feed efficiency, but it also allows you to increase the feed loading because that load is spread out during the day rather than concentrated in these pulses, okay? So the other thing to mention here about managing carrying capacity, and I like this example, again, I mentioned I work a lot with farmers in Ecuador. So basically what they have is a technology package. And I think you too probably have a technology package. In Ecuador, what they have are feeds that are much better than they used to be 10 or 15 years ago even. They're using a lot of automatic feeders. They're using multi-phase grow-out systems, nursery, phase 2, phase 3. I'll talk about that in a second. They're using more and more aeration. They're using bioremediation, probiotics and bioremediators. And they're also using genetically improved animals that are resistant to diseases. So here's an example of the effect of genetics. Okay, these are 3 different strains of shrimp, and you can see this one strain reaches market size in 50 days, this one in 63 days, this one in 75 days. Which would you prefer? So one of the ways to manage carrying capacity is to use good genetics. And what that allows you to do is to have more rotation. You just have more crops per year. Instead of 3 crops per year, you have 5 crops per year. Okay, you're managing, you reach that carrying capacity quicker. That's the idea with using good genetics. Now, this is an example to show what would happen if you stock small shrimp when they're really small like here, and you grow them up to your carrying capacity. So what this means is that all during this crop, or this part of the crop, you have a lot of unutilized carrying capacity in your ponds. So how to improve that situation? That's where these nursery systems come in. And rather than get into all the graphics, just kind of focus on the top lines here. With these nursery systems, because you can overlap the crops, you can get more crops per year. You get better survival and yield in grow-out. You have better growth rate in the grow-out systems because you're stocking a larger animal and it can just take off. And then you tend to have better feed conversion as well, okay? So this is an example. Now, here are some guidelines for stocking and managing these nursery systems. So basically, it depends on the size of animal that you want to move forward into the grow-out, whether you want to stock a really small animal, something slightly larger, or even a larger animal yet. And what you can see is the carrying capacity increases correspondingly. Smaller animals tend to have more they tend to be more sensitive in terms of the water quality requirements. So the carrying capacity levels are much less for the smaller shrimp than they are for the larger shrimp. You'll also notice again that the pond size increases with the larger animals. Pardon me? Yes, I'm almost done. I'm almost done. So, you know, this shows what the advantage is. If you get to a certain size and then the growth rate falls off because you've reached carrying capacity, you harvest, do a partial harvest, and then the growth rate improves again. So that's some advantage. I wanted to talk about this system in Vietnam. And with respect to this issue, there are two parts about it that are interesting. One is that they grow in a phased system. So they have a nursery for 25 to 30 days in 200 square meter tanks and a grow out for 70 to 80 days in larger tanks, 800 per square meter. They do 3 partial harvests, okay? 25%, 25%, 50% at different shrimp sizes. So this is a way to manage the carrying capacity with these partial harvests. And then you can see over here, this biomass level, these are the different carrying capacities for the different stages of the system. These round tanks have become increasingly popular. Once again, you can see the carrying capacity, this maximum biomass increases as you get into these larger animals because they have higher carrying capacity. All right, let me move past that. So just a couple slides in sum for this presentation. Carrying capacity of semi-intensive and intensive ponds is mostly limited by oxygen supply. You want to maintain that level at around 5 or 6 milligrams per liter. The loading limits for green water systems is around 200 to 300 kilos per hectare per day. And if you want to go beyond that, it becomes a bacterial system. It's a different phase of the culture cycle, if you will. Carrying capacity is a function of pond size, aeration rate, and solids removal effectiveness, okay? Carrying capacity of intensive ponds and super intensive tanks is limited by the accumulation of organic waste on the pond bottom. So you have to have some capacity to keep them clean with paddle wheel aeration and water exchange through a central drain. Carrying capacity can be increased by increasing feeding frequency, using these automatic feeders, using genetically improved shrimp stocks, and using multi-phase grow-out systems, okay? And managing carrying capacity is one of the keys to profitability. The index that you should be tracking is something called the production to capacity ratio. In other words, that's your turnover rate. Your C is your carrying capacity, whether you think it's 2 tons per hectare or 2.5 or 25 tons per hectare. And then how much you produce per year is an indication of how many crops per year, how much rotation, and how well you're utilizing the carrying capacity that you have. And with that, I'll stop, and thank you very much for your kind attention.
Thank you very much. Thank you very much, Dr. Hadi. Next, Dr. Miandrias, 30 minutes for your time, please.
Assalamu alaikum. First of all, I'd like to thank organizer for the invitation. And this is my second time as well here. I was here in 2018, and then COVID happened, and I wasn't able to make it. And today we're going to discuss about production of the quality shrimp feed for the use of automatic feeders. I think the previous speaker gave a very good idea about the feed, how much feed you can feed it, but how you make it good quality feed. That's what we're going to focus today. And I had here quick questions. What is quality? Basically, if you can see there, the definition-wise, it is the feature, the characteristics of a product or the service that bear its satisfaction as given need. Also, quality is basically a degree of excellence, and this is what the customer expect, and you give them every time they need that one. Therefore, first you have to understand what quality is in order to understand what quality feed is. Therefore, I have a question for the people who have here feed their shrimps. Have you ever counted 100 shrimp pellets and weighed them to see how many pellets are in 1 kilogram of feed? If you make a 1 kilogram of shrimp feed, and if the size is basically 1.5 millimeter, that is 62,500 pellets. And if that is 2 millimeter, that is 22,000 pellets. What that tells me that you have quite a few pellets that you need to take care that each pellet carry the same amount of nutrients. That is the most important thing here. Because if you look on the pellet, you can see there in this pellet we have to have some kind of proteins, minerals, feed additives, energy sources, and all that. Therefore, if you're making even 1 kilogram feed that has around 60,000 pellets, each pellet must carry all the nutrients in order for the shrimps to use that one. And that is what I'm trying to emphasize here, that you can see that in this one here, shrimp basically required more than 40 nutrients. Therefore, each small pellet you are making it, you have to have all the nutrients equally on these pellets in order to make it good quality feed. Feeding shrimp, actually, if you can see that the cost is around, feed cost is around 60% of the shrimp farming. Therefore, all your cost is right there. And of course, initial small ponds, grow out ponds, they usually distributed feed through the levees in the small ponds, or maybe with that small motors, boats. But if you know, using a larger ponds, we have to have automatic feeders, and it reduces the production cost, improve the shrimp growth rate, and improve the efficiency and profitability. That's what we are going to make here. So how can we make a quality pellet? Therefore, how do you make it good quality pellet which can withstand automatic feeders? It's important that the pellet has to be very durable. So it does not break during automatic feeders, and especially also break with the physical action, because it's mechanical, and then physical action take place, and pellet will break. Also, the pellet should not create any fines. Why? Because the fines basically will affect not only the feeder, but also it will reduce your water quality. Therefore, you don't want to create any fine. And it is important to understand breaking is not that important as how the pellet break itself. If the pellet is a good quality, you will not create too many fines. But if the pellet is a poor quality and we should break it, you are going to create a lot of fines. Therefore, it's very important to understand the pellet has durable, and even its break, it does not create any fines. And that is achieved by making a good quality pellets. And if you do not have a good quality pellets, this is what's going to happen to you, because during handling, you will see that you have all kind of fines that start producing already instead of having a water stable pellets. And what will happen that once you feed it in the ponds, less than 5 minutes or maybe 3 minutes, you will have all the water that we got polluted. The fines, the nutrients will leach out, and this is just making a water quality very bad, and of course shrimp can consume it. You want to make sure that pellets stable in the water for a long time, depending upon your requirements. Also, the pellet characteristics, physical pellet characteristics, will affect the efficiency of your automatic feeders. If the pellet is round or that's crushed, what are the angles of the pellets are, they are also going to be affecting it, basically your automatic feeders. Therefore, you have to be very, very careful. The pellet quality has to be consistent and uniform in order to the automatic feeder to be efficient. Then how do you make a good quality pellet? I gave you the background that we need a good quality pellet which does not break, which is durable, and it can be handled in the mechanical feeders. You need to focus on these three things. Number one is, of course, your raw material preparation. Second is going to be how you're going to extrude this one. And then the third one is drying of the pellet is also very important when you make it good quality pellets. What is a typical feed formulations? If you look over there, I was able to pull one from the internet. Basically, it has some kind of fish meals, shrimp meals, or squid meals, soybean meals, wheat, and oil. These are the typical raw meal choices you have it, that you need to make it your shrimp feed, and you have to understand how to prepare the raw materials. Therefore, everything starts with the raw materials and the preparation. If your preparation is not good, you will be stuck all day to making a small pellet. Because as at home, when we cook something, we prepare our food, we have prepared our vegetables, we peel them, we cut them, we wash them. Similarly, you have different kind of raw materials, and you need to start preparing the raw materials, and that is the most important thing you need to do it, to start preparing the raw materials. Shrimp feed preparation, you have to have very, very fine. Why? Because large particle will clog your die orifice in the extruders, and I'm going to show you small pellets and that plug dies, what happened. Also, it will affect abrasions, and the fine particle has less abrasion on the equipment. Plus also, it will expand much better protein to improve the binding of your pellet. Therefore, basically, you need to have a very, very fine powder in order to make a small pellet. This is very important. And you can see here, two different grinds. It's basically identical feedstock ground into two different sizes. And you can see that this is kind of 98 minus 250 microns. This is 80 screen, and you can see how nice is the powder is that. And that's going to make a good quality pellet. And you can see here, very uniform colors when you grind very fine. And finally, ground material has much more consistent color. When farmer is going to buy your pellet, he or she also going to focus the why this is, some pellets are light, some are dark. Therefore, if you have a uniform, a very nice grind, you're going to get a very, very nice color. Also, it indicating a better incorporation of the feedstock component, improved blending. Also, you will have a uniform pelleting and better feed delivery by if you use that fine grind. Also, oil, we use it, and in this case, it must also be sieved. Sometimes we don't pay attention, we pump the oil directly, but sometimes the oil has some sediments in it, and that also plug up your die. And we must add, because since it's a very, very small pellet, we usually add that into the internally, not after we make the feed. Therefore, the oil has to be, make sure there is no sediment, otherwise that also plug up your die there as well. Water and steam lines. You can see that sometimes we pay attention on our steam systems. We have a lot of corrosions and dust. If that go with the steam, it can plug up your die. Therefore, you want to make sure that also your water and steam also must be filtered so that you remove everything from the lines. Otherwise, it will go some of the rust, some of the particles, sediments, and they can also plug up your easily your dies and other system there. This is a typical system where we use it to make a quality pellet feed, durable. You have a mixers, you have a pulverizer, we're going to pulverize it. Then of course sift it again, go to the extruders, then of course we're going to go to the dryers, then cool, then after that we can sieve it, and then we can recycle the waste and pack the good quality pellet which we needed. For that one, first is the mixing. You need a dedicated mixer. You can't just use a mixer which you are using it for some other formulation, because very easy will you get contamination. Therefore, you have to dedicate a special mixer if you're going to make a shrimp feed only for that, because if you use that mixer for other feeds, there are the chances that you will get some larger particle or some contamination. And also it has to be scaled up to your extrusion system. After that, you need of course, Hammond mill is only limited to 0.8 millimeter grind size. And you need to go to 40 mesh or 80 mesh. You need to use a good quality pulverizer. And for that, you can't use the Hammond mill. You have to pulverize your raw materials in order to make it very nice fine grind. And you can see here, also, when you grind it, you must also sift it after pulverizing it, your material, because sometimes some particle will escape. And there are different kind of sifters that people use it. You can see here, 2 pallets side by side. Only difference is just the small grind size. And you can see there's a lot of fines on the pallet. But for basically, you want to make it consistent fine grinding. You don't want to create a lot of heat in the grinding, because you will prevent your, otherwise you will lose your nutrient. Also, it's very essential to make sure that you have a sifting, continuous sifting in the system. And you can recycle your oversized materials, and you can have a self-screening cleaning screens. And this is, you can see here the pulverizer, and then you can see there is basically a sifter which goes after that. You add your materials here, and then of course it will sift it. You can't see it behind the chairs, but all that ground materials come this side, and the over materials come from the other side, and you can remove that one, and then you can recycle that as well later on. This is the reason that we want to make sure we grind and sift. This was a ground materials, but was not sifted. If you don't sift it, you can see that some of the particle will come up with the dyes, and then it will basically clog your dyes, and then you're done for the day. It's going to take you for half a day to just take it apart your machine and clean it, and then go back into the operation. Therefore, after pulverizing, sifting is must. You must sift it just to make sure there's not any larger particles are there. And you can see here the result. This is pulverized. This is pulverized and sifted. And here you can see a 450 microns was 99.8. This is 100%. 350, 99.2, 100%, 100%, 99.8. And you can see there just pulverizer does not do a complete job. You must also sift it in order to make sure you get 100% what you're looking for in order to make it small pellet. Then you have to have a good quality extruders, which has a good quality preconditioner. You have an option to use a back pressure valve, and then you are going to use a special oblique die to densify the pellet so we can make it sinking pellet for the shrimp feed. This is a back pressure valve which can control your cook level so that you do not want to expand, you want to cook it, and we can control all our SME through using a back pressure valve just before the die. After the barrel, most of the shrimp manufacturer will use that one in order to control the density. This one, you also have a very special preconditioner. If you can see this one here, this is basically a high shear conditioner which compact the materials, remove all the airs so that you do not make a floating feed, you make all sinking feed. Therefore, this is basically is very specialized filter, decreasing volume, increasing the shear rate. As you inject the water and the materials here, you can see that it's going to compress more and more so that all the air will evaporate, and you have very special, this kind of mixer that you can use it for the shrimp, especially shrimp formula. This is the mixer recommended to be used to make that shrimp feed. And then also for making it very small, you have to use a twin screw extruders. You can't use a single screw extruders if you're familiar with that, because single will not handle a very small particle. You have a twin screw extruder, and that has a special die on the end, which has, of course, very 3 different outlets, so you can increase your capacity. And of course, you can, these are also, what happen is they deaerate the materials, and it allow you to make a maximum density product which is sinking for the shrimp feed. This is to show there that you have here one die, but in this case you can also, on the end of that, you can use two different dies to increase your capacity, and you can make it easily 0.6 millimeter extruded feed, shrimp feed, which will be sinking feed there. Yeah, you can make it. This has a population of 3 times not than the normal, because these are 3 different holes. And then of course this one, each of them has quite a few opening there. Therefore this long tube increase the cook level, decrease that expansion through the pressure, drop and the retention time. And of course this small tube will give you very, very uniform, especially cross-section flow, and then you can have very nice small pellet there without any problem with that one. These oblique die, you have also a special knife for them that you use it, so you can cut that one on this screen. And these are used to make it very high rate, like 5 tons, 6 tons per hour. It's very uniform sizes. All the pellets are the same size. You don't make a smaller or larger pellet. Greater product density, has a higher rate for the sinking, increased water stability, and of course much better your pellet durability. This one here, you can see here advancement, as I said. And this is an extruder, and instead of having only one die which has a 3 again opening, you can have a 2 die like that diversion, so you can make it much more higher capacity your shrimp feed, and that's being used in the industry so that it can compete with the pellet mills and make a good quality feed there as well. After that, once you make the pellet, drying is very important. Dryer of the choice for the product, if you have less than 1.2 millimeter, you better use some kind of fluid bed dryer. And also you can use it conveyor dryer, which is less than 1.2 millimeter. You must have a screen for that, and they have limited bed depth. And of course you can have it also circulation fan, and you can have a 0.7, 0.8 millimeter pellet there to dry that in that case as well. This is, you can see here, typical dryers they use for the shrimp feed. It has a spreaders, conveyor belts, fans, heat sources, makeup air, exhaust outlet, and you will use that one to dry that. But the most important thing is that's also your conveyor belt. Like for 1 millimeters or 1,000 microns opening were required for that larger than 1 millimeter. And also some of these, your synthetic screen must be very high temperature. They can resist that one during the drying process. You can see here, this is the mesh conveyors, screen conveyors, and of course it can retain 0.8 millimeter diameter feed and allow you maximum the airflow goes through there so that we can remove the moisture. And also you need a very, very uniform spreading of this feed in order to dry that one. Because sometimes you have uneven drying, and that's when you will see that some issues comes up with the mold and some other issues later on. This is the production data. And if you can see here, sinking percentage, 100% when they're making it 8,000 kilograms, 99% when they were making it 10,000 kilograms. Wet density was 675, dry density was 685, water stability, more than 6 hours. That is when you make a quality feed. You have to make the pellet which is durable and which can stay in the water for longer time. Most of the times when you get that with the pellet mills and other processing, your life is like less than 5 minutes. But these extruders allow you to make it which has more than at least 6 to 7 hours. Uniformity, they're all uniform pellets, less than 0.5%. Expansion, that's less than 3%. And the color was very, very dark brown and uniform colors. And you can see here shrimp feed, extruded feed, depending upon what size you need it. You can cut this pellet based upon your requirements, and you can make it this kind of stable feed. This is again 0.8 millimeter. directly extruded sinking feed for the shrimp made with the extrusion system. This is 0.6 millimeter sinking feed made with the, again with the shrimp feed. This is a 0.4 millimeter made with that shrimp feed. Therefore, you can increase your feed pellet quality by extrusion by reducing that waste, because you don't have any fines there that will be wasted. It increases nutrient density, it improves pelletability, increase nutrient availability, and of course decrease microbiological activity. Therefore, you can see there when the shrimp eat the pellet is still durable, it does not break into, so that it can nutrients can go into the water. Also, with that, you can get very good pellet durability, you can control of the pellet hardness, and of course, you can make it less than 2 millimeter or even less than that in case with the extrusion process very easily. When you make it durable pellet, you produce less fine. What that means? Less fine means you have increased water stability, your pounds are very clear, lower fertility rate, you have less undesirable bacteria, you increase conversion rate, higher production yield, improve digestibility, and reduce your feed cost. Therefore, basically, you do not want any fines to go into the water. You want to make sure that all the fines, pellet doesn't have any fine when you feed, because special of the mechanical measure. And you can see here, this was here for 4 hours, this pelleted feed, with the extruded feed. And you can see that there is any nutrient leaching. Water is very clear. That's the beauty of the durable pellet, quality pellet, that you make it 4 hours and you don't have any leaching of the nutrients. It stays like that, and water is very, very clear as of now after 4 hours. Therefore, what is the bottlenecks? Why cannot everybody or any extruder manufacturer make the shrimp feed with extruders and all that? These are some of the bottlenecks. You have to have a mixing and grinding capacities, especially the mixing and grinding. You have to have a conveying capacity that you can convey your pellet, very fine pellet. You must have a good extrusion capacities. You must have a drying capacities. You have a sifting and dust control, pneumatic system, sanitation and HACCP requirements, and also have a dedicated line. You can't use it making it regular feed and then start using it with a shrimp feed, because this will contaminate the lines and then you will have issues. If these are some of the bottlenecks that you will find it in the industry. That's why most of the people will not be able to make it, because these are the limitation. A typical feed industry will have that one. And you want to make sure if you're going to do that, you have a dedicated facility for that. Therefore, this is the extruders that we're talking about. And that can basically make it very, very nice, produce a sinking feed for the shrimp if you have a good quality system there. And of course, the raw material is number one, the preparation, I talk about it, and good quality extruders, and then the drying. If you want to learn more about extrusion, I have published 3 books. One is from USA, and one is from Germany, one is from UK. I do have these 2 books with me here, in case somebody wants to see that one. And you can also Google it, and you can find it easily. Also, if anybody is going to VIV next week, I'll be also there organizing it, one-day sessions, conference, and there are a lot of manufacturers of extruders will be talking about shrimp feed. Anybody like to go there, please see me, and I can give you some discount or some of that registration code that you can register it if anybody going to VIV next week. With that, I still have 3-4 minutes, and I'm going to show you a small video here. This is that extruders in India, that is with oblique die. I talk about it. And they are making it shrimp feed, a very good quality. You can see this one here. These are the 2 dies. This is the extruders I talk about it with the preconditioner. They have simple preconditioner, and they have this also. And then there's 2 dies on the end. So these are the extruder which is now making it pellet feed with the shrimp feed especially. And they are making it 5 tons to 6 tons per hour. And this is all controlled by the computer system there. This is what is a control panel is. They are controlling it with that. Thank you very much. And if there's any question, we'll be happy to answer. Still have 3 minutes.
The next presenter, I would like to invite Professor Agus, please. Yes.
Assalamualaikum warahmatullahi wabarakatuh. Selamat siang. Pertama-tama saya mengucapkan terima kasih telah diundang di sini, sangat senang. Terima kasih Kang Denny, Kang Pamuji dari GPMT dan USSEC. Baik, tadi saya pikir sudah banyak yang dibahas. Saya akan membahas yang lebih mikro lagi mungkin ya, ini terkait dengan pakan. Dan di dalam pakan itu juga sendiri hanya saya bahas bagian dari mineral. Jadi mungkin ini bagian yang sangat kecil dari usaha keberhasilan suatu sistem budidaya udang. Baik, ya saya lupa menyebutkan terima kasih juga ada Kang Ujang, Direktur Pakan dan Obat Ikan. Dan rekan-rekan semua, baik, topik saya di sini adalah saya akan berbicara trace element di dalam pakan. Spesifiknya saya akan berbicara peran selenium terhadap antioksidan, pertumbuhan dan kesehatan udang. Oke, baik, mungkin kita semua tahu saat ini 3 tantangan besar budidaya udang adalah, pertama adalah harga pakan yang cenderung terus menaik, dan ini karena givennya kita tidak bisa menghindar ini karena memang ini adalah kenaikan dari harga bahan baku. Yang kedua, harga udang yang belum juga cenderung pulih. Yang ketiga adalah penyakit yang memang timbul, berbagai macam penyakit. Ini semua tentunya di satu pihak menjadi constraint, sehingga tingkat keberhasilannya ini mesti lebih tinggi lagi, atau koefisien teknis yang dipasang di tambak sebagai FCR, SR itu mesti lebih tinggi lagi agar margin yang sebelum didapat itu bisa tercapai. Nah, kalau kita lihat penyakitnya adalah suatu akibat. Nah, mungkin di sini akan kita bahas, dan saya akan fokus bahas ke bagian feednya. Oke. Pertama saya akan berbicara apa dulu itu pakan. Jadi pakan itu adalah edible material. Jadi bagian yang bisa dimakan yang bertanggung jawab. Jadi setelah dia masuk ke dalam tubuh, dia harus bertanggung jawab terhadap 3 hal. Yang pertama adalah repair and maintenance. Kemudian dia bertanggung jawab terhadap growth dan development. Dan yang ketiga, dia juga harus bertanggung jawab terhadap protect from infection and diseases. Jadi inilah fungsi dari feed. Dia harus cover 3 fungsi ini. Jadi kalau sekarang berkembang isu functional feed, sebenarnya semua feed ya harus mengandung 2 fungsi utama. Growth, body cell repair, dan protect infection and disease. Jadi yang berbeda hanya 2 sebenarnya. Pakan untuk benih, induk, dan pembesaran. Tapi dia harus disease dan body repair harus covering. Jadi itulah pakan itu bisa didefinisikan sebagai the truth pakan gitu. Baik Bapak Ibu sekalian, Hal kedua yang perlu diperhatikan dari pakan ini adalah pakan itu berkontribusi terhadap production cost terbesar dibandingkan komponen-komponen lainnya, komponen input lainnya. Hal ketiga juga pakan inilah yang memberikan waste terbesar terhadap kolam yang akan menjadi umpan balik negatif terhadap organisme budidaya yang kita pelihara. Jadi disinilah saya pikir kompleksitas yang akan terjadi jika kita memasukkan pakan ke dalam kolam. Lanjut. Mungkin di sini saya akan menggambarkan kita lihat saat ini saya pikir hampir semua budidaya udang itu dilakukan dengan stocking density yang cukup tinggi. Nah, dampak dari stocking density yang cukup tinggi sebenarnya tanpa dikasih apapun dia sudah menimbulkan suatu oxidative stress. Jadi makin tinggi udang yang kita tanam, sebenarnya cekaman yang diterima juga semakin tinggi. Yang kedua, konsekuensi dari high stocking density ini, kita akan butuh pakan yang lebih banyak. Kita akan menghasilkan waste yang juga lebih banyak. Tadi sudah dibahas ya tentang carrying capacity. Di sini juga saya pikir menjadi penting antara density, feed, dan waste serta carrying capacity dari suatu kolam. Nah, kesemuanya ini akan membuat kondisi lingkungan menjadi tidak baik. Nah, ini juga akan menyebabkan oxidative stress. Apa dampak dari oxidative stress? Ini kita lihat bahwa oxidative stress ini menghasilkan reaktif oksigen species, hasil metabolik oksidatif, menghasilkan 3 senyawa ya, O2-, OH- dan peroksida. Nah, ketiganya ini akan direspon oleh tubuh. Respon yang pertama terlihat jika oxidative stress ini sudah melebihi batas ambang adalah nafsu makan dan kemampuan cerna udang itu akan turun. Yang kedua, akan menyebabkan atau menginduksi terjadinya deaminasi oksidatif. Apa itu deaminasi oksidatif? Deaminasi oksidatif itulah pemecahan protein menjadi energi. Sehingga di situ akan dihasilkan limbah nitrogen waste. Nah, ini juga akan menginduksi kondisi kolam menjadi kualitas airnya menjadi lebih kurang baik, dan ini akan kembali lagi menyebabkan stres oksidatif. Ini adalah suatu perputaran yang terus-menerus terjadi. Oleh karena itu, saya pikir di sini juga tadi sudah dibahas bagaimana kita mengelola feeding management, water quality management, dan health management di sini. Kemudian, kalau kita lihat lebih lanjut, apa dampak dari respon fisiologis dari turunnya nafsu makan, pencernaan, dan deaminasi oksidatif? Ini adalah turunnya imun respon. Nah, dampak dari semuanya ini resultantenya adalah terjadinya disease outbreak. Nah, inilah kira-kira salah satu penyebab terjadinya outbreak di kolam. Mungkin ada faktor lainnya seperti misalnya bakteri, tapi triggeringnya dari sini, karena kita yakin sebelum kolam kita tebar itu kita persiapkan, kita kasih treatment, kita bunuh, tapi tetap aja ini akan terjadi gitu. Nah, jadi ini menjadi dua hal penting yang perlu kita perhatikan. Oke. Nah, dari sini kita lihat penyebab utamanya adalah oxidative stress. Kira-kira apa bagian dari pakan yang memang dapat menanggulangi ini, dari oxidative stress ini? Nah, saya akan masuk ke dalam topik tadi, ya, suatu konsepsi dasar dulu, suatu teori yang apa peran daripada nutrien tersebut yang dapat mengantisipasi stres oksidatif ini. Nah, kita masuk ke selenium, ya. Selenium ini saya pikir ini adalah suatu trace element yang kelihatannya dengar namanya kayaknya masuk ke kategori hampir ke logam berat ya, logam memang ini, tapi kalau tidak ada ini sangat berbahaya di dalam pakan. Nah, kita lihat Ya, jadi selenium ini adalah salah satu nutrien, bukan nutrien lah, selenium ini satu zat ya, unsur yang memiliki fungsi sebagai antioksidan. Nah, antioksidan itu kalau kita lihat perannya nanti ya, di sini antioksidan adalah suatu zat yang dapat menghidrolisis atau menetralisir berbagai macam reaktif oksigen spesies tadi. Nah, jika seperti saya katakan tadi, prooksidannya ini lebih besar daripada kemampuan oksidannya, maka stres oksidatif itu terjadi. Tapi bila di counter, maka itu dapat dihandle atau diatasi melalui tiga hal. Ya, yang pertama adalah dengan dihasilkannya SOD. SOD ini menghidrolisis O2- ya menjadi H2O2, kemudian H2O2 ini dinetralisir oleh glutathione peroksidase yang intinya adalah selenium ini. Jadi ini adalah selenoenzyme. Yang kedua, jadi dia berperan sebagai antioksidan. Yang ketiga, selenium ini adalah suatu zat juga yang memfasilitasi ya dalam bentuk iodotrionin diiodinase atau selenoenzyme yang mengubah inaktif tiroid jadi aktif. Ini akan menginduksi ya metabolisme di mana di situ digeretak ya insulin secretion dalam sel yang selanjutnya akan meningkatkan nutrient metabolism and retention. Jadi di sini retensinya meningkat, kemudian intake feednya meningkat dan juga akhirnya akan meningkatkan pertumbuhan. Ya. Jadi dua fungsi utamanya dan fungsi ketiga dari selenium ini adalah dia juga men-trigger ya cellular immunity dan humoral immunity. Nah, itulah dari tiga fungsi selenium yang nanti akan kita bahas dengan berbagai macam data yang kita punya. Nah, dari konsepsi dasar ini kita masuk ke dalam suatu artikel ya. Ini adalah kita publish di tahun 2022 mengenai selenoprotein terhadap digestibility, growth, health performance of Pacific White Shrimp Lithopenis pandemi ya. Ini baru saja kita publish. Jadi di sini kita mencoba ya tes diet nih kita dengan protein 31 kita tambahkan selenoprotein dengan berbagai macam level, graded level. Kemudian di sini kita cek selenium level ini selenium sebelum kita tambahkan selenium ini pakannya sudah mengandung 0,77 selenium. Kemudian ini pakannya mengandung 1,27 selenium, 2,8 dan 2,72. Jadi kita punya 4 graded level daripada selenium di dalam pakan. Nah, pakannya ini base-nya 31. Nah, ini kenapa 28 karena di sini moisture kita tingkatin. Tapi kalau kita balik ke base-nya lagi sama semua 31% proteinnya. Baik. Setelah ini kita coba di udang. Setelah kita coba kita lihat apa yang terjadi terhadap total digestibility, protein digestibility dan energy digestibility. Hampir semua yang kita suplementasi selenium meningkatkan total digestibility, meningkatkan protein digestibility dan energy digestibility. Jadi tiga komponen dari penting dari kecerdaan ini terlihat meningkat semua dengan penambahan selenium. Kemudian kita lihat apa yang terjadi dengan growth performance. Growth performance daripada udang yang kita berikan. Oh ya, udang ini kita pelihara dari selama 70 hari ya, dari PL8. Kemudian setelah itu kita coba lihat growth-nya. Nah, kita lihat di sini ya. ADG udang yang diberi selenium ini meningkat ya, persentasenya dibandingkan kontrol sebesar 3,6%. 6,22% dan 12%. Jadi terlihat sekali bahwa walaupun selenium itu ada ternyata jumlahnya masih kurang. Kalau kita tambahkan lagi dia meningkat. Kita lihat FCR-nya ya, yang diberi selenium jauh lebih baik daripada yang tidak diberi suplementasi selenium. Bagaimana dengan retensi protein? Nah, apa itu retensi protein? Retensi protein itulah banyaknya protein yang disimpan di dalam tubuh dibagi dengan protein intake. Jadi semakin tinggi retensi protein, maka protein yang dirombak di mana buangannya adalah limbah amonia itu semakin kecil. Nah, ini kita lihat protein retentionnya ini meningkat dengan meningkatnya level selenium di dalam diet, di dalam pakan. Dan ini statistically difference ya. Oke. Kemudian kita lihat ke antioksidan kapasitinya. Ya. Jadi, nah di antioksidan kapasiti ini ada 2 tes. Ini setelah 70 hari kita tes antioksidannya, kemudian kita tantang dengan P-video parahemolyticus, kemudian kita cek lagi. Jadi before challenge dan after challenge. Apa itu MDA? MDA ini adalah suatu senyawa yang dihasilkan oleh sel jika dia mengalami stres oksidatif. Artinya, jika MDA-nya tinggi, maka sel itu dalam cekaman. Namanya malondialdehyde. Nah, kita lihat di sini, nilai MDA-nya ini udang yang diberi selenium jauh lebih rendah daripada udang yang tidak diberi selenium. Dan setelah kita challenge test, ternyata juga sama. Yang diberi selenium jauh lebih rendah daripada yang tidak diberi selenium. Artinya selenium ini memang works untuk meningkatkan antioksidan capacity baik before infection ataupun after infection. Yang kedua, kita lihat di sini ada SOD. Apa itu SOD? SOD itu adalah suatu enzim yang menghidrolisis O2-amin menjadi H2O2. Kemudian H2O2 itu hidrogen peroksida. Nah, ini sangat reaktif sekali di dalam tubuh, yang mana H2O2 itu langsung dinetralkan oleh GPX menjadi H2O dan O2. Nah, ini kita lihat SOD-nya yang diberi selenium itu juga meningkat. Hampir 30% lebih tinggi daripada yang tidak diberi selenium sebelum dan sesudah di challenge test. Bagaimana GPX ini bagian enzim dari seleniumnya sendiri, kita lihat juga sama. Jadi peningkatan aktivitas GPX sebelum baik yang hampir semua pakan yang disuplementasi selenium sebelum dan sesudah di challenge. Bagaimana dengan imunitinya? Kita lihat di sini, kita lihat ada THC, ya, cellular immunity. Kita lihat di sini ternyata selenium juga meningkatkan, ya. Bagaimana total hemosit count-nya ini setelah challenge test. Jadi 70 hari kita tantang, kemudian kita hitung, ternyata yang dikasih selenium ini menunjukkan total THC hampir 2 kali lipat dibanding yang kontrol negatif. Kemudian bagaimana dengan pagositoxic activity-nya? Kita lihat di sini ya, kemampuan mempagositosis dari benda-benda asing juga yang ditambah selenium ini meningkat. Dan bagaimana ini salah satu pertahanan penting dari udangnya, propanol oksidase ekspresi gennya, ini juga kita analisa ekspresi gennya. Jadi mRNA propanol oksidasenya ini setelah 48 jam infeksi juga meningkat. Ini adalah suatu enzim yang akan memelanisasi bakteria sehingga dia jadi inaktif. Jadi kita lihat di sini dari immunity result-nya pun bahwa suplementasi selenium ini memberikan dampak positif terhadap sistem imun daripada udang uji. Ini saya pikir data terakhir, ini adalah dasar resultante. Jadi kita lihat di sini setelah 70 hari ya, ini kita lakukan challenge test, kita lihat di sini SR-nya ini yang tidak kita beli selenium jauh lebih rendah daripada yang pakan-pakan yang diberikan selenium. Nah, slide saya terakhir. Jadi dari data yang kita dapat, konsepsi teori yang ada, yes, selenium ini sangat esensial. Pertanyaan kedua, apakah semua pakan sudah ada seleniumnya? Jawabannya pasti. Yang ketiga, kenapa ini masih terjadi? Ayo kita diskusikan sama-sama. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang.
Bapak dan Ibu sekalian, kita berikutnya ada satu presentasi secara virtual yang akan dibawakan oleh Robert Blank dari yang mengenai recent update on shrimp genetic and post larvae quality. So, it is possible to connect? Okay. Mr. Robert Blank. Oh, sorry.
Hello, you can hear me now?
Yeah. Now you can present. Okay.
Oh, nice. Thank you.
Your
Yes.
time for 30 minutes. Please.
I'm going to share my screen. Okay. And I think you can see it now.
Yes.
Yeah, I think that's better. Okay. Good afternoon, everybody. Thank you very much for the invitation for this presentation. It gives us a nice opportunity to present the work that we're doing and how we are contributing to the shrimp culture in Indonesia. My name is Robert Blonk. I'm a Director for Research and Development in Hendrix Genetics Aquaculture. I will tell a little bit about what Hendrix Genetics is doing. And then I will explain about a little bit about breeding, what is breeding doing, how can it help aquaculture, and how can it specifically help in aquaculture in Indonesia. Hendrix Genetics is a multi-species breeding company. We are operating in roughly 26 countries in the world, globally, and we have more than 3,000 employees currently. We are a big company, especially in layers and in turkey production. Layers, we are also represented in Indonesia itself. But we are producing eggs for laying chickens for the whole world, and also we are active in turkey production, mainly in Canada and in the US and in Europe. We have a swine division also represented globally, and a broiler company for production of local broiler breeds. But more important, and that's I think, and it's also my favorite part of Hendrix Genetics, is the aquaculture business unit. Here we produce salmon, trout, and shrimp, of course. And I will explain a little bit more about that. So our aquaculture business unit is present in several countries. You can see that highlighted here in green. Let me quickly get a pointer. There we are. So we're producing, well, we're based in the Netherlands. That's where the Hendrix Genetics headquarters is. But we have operations in Scotland, in Chile, in Ecuador, in the US, both in mainland and also in Hawaii, India, Indonesia, and Malaysia. So this is where we're operating, but we're selling globally most of our products. Yes, so if we zoom in on the map a little bit, like I was saying, we are producing in multiple parts of the world. And for example, in the UK, and specifically in Scotland, we are producing Atlantic salmon. Atlantic salmon facilities, we also operate in Chile, where we have our own nucleus, but also work with other parties to produce their breeding program. In the US, based on mainland Washington State, we have the rainbow trout production, also selection programs. And then again, most important in this context of this presentation, we have our shrimp breeding facilities. One is located in the island of Kauai, the state of Hawaii, US, serving mainly the market in Asia, where we have reproduction facilities in Indonesia currently, together with our partner STP, but also we are building a big multiplication center in India. We have a small facility in Malaysia. Then also we have a breeding program in Ecuador, which is separate from the programming based in Hawaii. And the Ecuadorian program is only producing PL post-larvae for the Ecuadorian market. So we operate all these breeding programs as Hendrix Genetics, as a company, of course, but we're always supported with a broad network of agents, sales representatives, technical people, but also scientific partners and business partners, of course. Zooming in a little bit, but briefly on our facilities in the different facilities of the different species that we're having. Like I mentioned, we are breeding Atlantic salmon in Scotland. This is a facility that started in roughly in the 1980s, so it's pretty old already. Here we have the capacity of the Atlantic salmon, a full land-based Atlantic salmon breeding program, completely biosecure. We produce roughly 40 million eggs on a yearly basis. So like I mentioned, in Scotland, our program started in the 1980s, but in 2016, we started another breeding program in Chile, which is basically a copy of our program in Scotland. We moved genetic material into Chile to have a local breeding program that really serves the local market, so we can adjust our selections to get a better product for specifically the Chilean market. Here we also produce Atlantic salmon, and we have a full brand new facility that's completely biosecure. Trout Lodge, just briefly, we are one of the biggest trout breeding companies globally. We produce roughly 500 million eggs on a yearly basis. This is all based from our nucleus facilities, and nucleus is our breeding facility where all the breeding happens, which is based in the US. We have 6 different farms as a multiplier to produce all the eggs. And our sales are globally, and that means US, Europe, Latin America, Asia even. Kona Bay and Hendrix Genetics Ecuador, both our shrimp breeding facilities. Kona Bay is the brand that we are producing specifically for the Asian market, where we sell broodstock, intended for hatcheries and to produce local PL in the Asian region. Our company is based in Hawaii, as you know, which is a complete SPF facility, biosecure for a very long period of time already, and a wide sales distribution network. Ecuador is a company that we started 4 years ago. It's a separate company, completely independent of the Hawaiian operation, with its own brand new nucleus center, breeding center, testing environments, and also PL production for the, like I mentioned, local Ecuadorian market. And last but not least, and then I will get into more genetic detail and tell a little bit more about our breeding programs, but Hendrix Genetics Aquaculture is also offering genetic support to third-party companies that want to have their own breeding program. We do that for different breeds of salmon currently. We help them in setting up the breeding program, doing all the breeding value calculations, everything, but also technical support around broodstock management, for example, and laboratory management. But into breeding. What is breeding and how did it develop and how did we get where we are today? You may know that aquaculture species, and that includes shrimp are relatively recently domesticated. For a long period of time, the older aquaculture, I should say, protein production coming from fish species, shrimp, mollusks, is coming from fisheries. That's quite different if you compare to poultry and swine production, where already for thousands of years there's domestication going on. And that means also breeding in some way. Aquaculture, this is way more recent. You could say that it's only in the 70s and 80s that more or less industrial scale breeding programs started for aquaculture species. Generally, and then they don't include, for example, carp production in Asia, because that's already being bred and domesticated for a very long time. But I would say that the 70s to 80s, we started salmon breeding programs, and also the first shrimp selection program started. But this was basic breeding, where we just basically picked out the biggest animal and the animal that did not die, and that is the animal that served to produce the next generation. It's between the 80s and 2010 that we started to get more detailed selection technology. This is, for example, family selection, where we used information from entire families to base our selection on, to use animals for the next generation. Pedigree information, so brothers and sisters, of course, but also cousins, but parental information was used here. And on top of that, multiple traits at the same time, so not only a body weight or survival, for example. Between 2010 and 20s, genomic selection started. This is a way more detailed way of getting information from for selection. I will tell a little bit more about it later in the presentation. And then we have gene editing, and this is where we are today, technology where we really try to adjust the DNA sequence. This is actually still in a research phase. Companies are testing, and we do that as well as Hendrix Genetics, testing whether, for example, gene editing could be used in breeding, but currently today this is not used for breeding at all. It's just in a research phase. So, and it's important to say that with the development of breeding, it's not only breeding that started, that was improving and getting more detailed and creating better ways of selection, but also production systems. The nutrition started to change, and all these different factors made it possible to get a more effective and more efficient product, animal production and protein production. So what is selection? How does breeding work in general? And I think the key here is that selective breeding is used to improve every generation. We don't go back to wild animals from the field, from the sea, or for example, to get new genetic material to create a new genetic product. No, we're using every generation to improve the next generation, and that generation is used to improve the next generation. Again, we should never go back to the wild. So how does that look in, if I would explain it in these plots, for example? Consider a population of animals. Well, you will recognize this. So, for example, this could be a low phenotype, and at the right side of the curve, you would see high phenotypes in the distribution. Could be body weight, for example, big animals, small animals. We would consider one population at the same age and evaluate them for their genetic potential. You could put this family, this first population at, say, for example, 100% performance. I will show how the selection would work. So based on the phenotypes, you could say we'll look at only the highest part of this distribution, and we will use those animals to produce the next generation. So what happens is the next generation, so the offspring coming from the animals in the first generation, would all be based on parents that are genetically better in the first population. So genetically seen, the offspring population is also improved. For example, with a better body weight of 10% extra. So the next level of this new generation is 110%. Here, we would do exactly the same. We, again, would select the best animals from the latest generation, and we would start to use them for breeding to produce the next generation. And what happens, again, our generation, our distribution shifts to the right, and the overall new generation, the third generation already, is 120% compared to the first generation that was only 100. So you see an increase of performance of the phenotype in this case, in this population. And we do that again. We select the top animals, they produce a new generation, and the next generation again shifts. And then we already are at 30% higher than the first generation. And we can only achieve that better 30% because we keep on selecting generation on generation, going back to the wild to start populations, and non-domesticated population would immediately set back our total phenotype, our total production capacity back to the 100%. So really reduce in performance. So it's important to realize that genetic breeding is about improvement generation on generation on generation. That also means that our animals change over time. They always change. They're never stable. Every new generation in shrimp, it could be every 6 months. For example, in our case, every 6 months, our product is improved. So it changed a little bit in terms of behavior, in capacity requirements compared to the first or the generation before. So what does that mean practically for farmers, for farming companies? Is that the better you are in terms of selection of your population, the more genetic gain you can make. For example, you could make a 10% generation improvement, but it could also be 5 or 2% only. Because this is working like an interest that you would get on the bank when you put your money on the bank, basically. Generation on generation, you would see that a good breeding program that is well structured and well performing, that could, for example, gain a 10% generation improvement every generation, compared to a breeding program that is not as well structured, still getting some improvement, but significantly less. For example, 2%, the big program would get much bigger gain. And in the beginning, you wouldn't see a big difference yet, but over time, this change will get bigger and bigger and bigger. That means basically that better breeding programs ultimately will always produce better shrimp, fish, chickens, doesn't matter, the same, it works in the same way. If you would look at the 5% versus the 2% difference in quality of the breeding program, that would mean that in 20 generations, you would get a 70% difference, for example, between the two different genetic lines, the breeding programs. And in shrimp, that could be in 10 years already. So that can go pretty quick. So genetic breeding programs, how do they work? Like I said, we are evaluating a whole population in order to find the best animals. Those are the ones that we want to select. We do that by careful data collection on the traits of interest. That can be multiple traits. I will say a little bit about that. And we can focus on one trait, just body weight, but we can also include other traits. We collect that data. We look at the data. We take into account the pedigree information, sometimes genomic information. We put all the data together in a database. We use that information to select, to create the next generation, and we start all over again. Again, we do data collection, evaluation, selection. It's a continuous cycle. And you could say for shrimp, this cycle it repeats every 6 months. Now, an important part of how Hanuk Genetics runs the breeding programs is this cycle that I just explained, continuous data collection. We do a selection, we create new families for the breeding program. We evaluate again, we do a selection. This continuously is going on. And for example, the facility that we're having in Hawaii, the SPF facility, this is all under biosecure conditions. Now, what we also do is we send out brothers and sisters of animals that are in the nucleus, in the biosecure facility. And we send them out to what we call sentinel ponds. These are commercial ponds where we evaluate the performance of the animals under SPF conditions, but we test them in commercial, dirty environment, you could say, to see which families in the biosecure facility are actually performing better. And we do the same with specific disease challenges. We challenge animals, brothers and sisters coming from the nucleus. We test them under challenge lab conditions for really tough environment in terms of disease challenges. And we use the information coming from the sentinel ponds and the challenges to use it back into the nucleus, and we use it as part of the data to select our new candidates to produce the next generation. And out of this biosecure SPF condition nucleus, where we selected animals based on commercial performance, we also select the animals that finally produce the broodstock that we are selling, for example, that we're distributing in Asia. So in this way, we try to get a product that is still SPF, but also commercially capable to resist the tough conditions. A little bit into genomic selection. What is genomic selection? I already mentioned before. Standard breeding programs use pedigree-based selection, meaning I'm looking at an animal, I evaluate whether it's capable to produce the next generation, whether it's a good possible candidate for selection. We do that based on information from brothers and sisters that we tested in, like I said, in sentinels and in challenges. And we do the same using information from cousins and parents and sisters and everything. Genomic selection is different. It goes into much more detail. What we do here is, first, we start with what we call a training population. Again, we use brothers and sisters of the animals coming from the nucleus. We put them in a laboratory. We test them, for example, on EMS. We take, as a first step, the phenotype. So we challenge these animals in a laboratory. We collect whether the animals die, like the orange ones, or whether animals survive. We look at how they survive. Are they still growing at the same time or not? And we use this information, we put it in our database. At the same time, from the animals that are challenged in the laboratory, where we collected phenotypes on, we also collect DNA markers. Basically, DNA tissue, we genotype this tissue and the DNA information to take out the specific DNA markers, thousands different points in the DNA, and we put that in the database as well. So we have DNA profiles of all the animals in the challenge. The database makes an association between all those different DNA markers and the phenotype. So some DNA may point, will be associated, some DNA markers, with dying animals, with mortality, and some others will be associated with survival and good growth at the same time. So that's what we do with the training population. Having that information, we start to look in the selection candidates, where we have different animals in the SPF nucleus, like I said. From the same animals, we also take DNA samples, and we genotype these animals for the same DNA marker. So for all those different points in the DNA, that we get the same profiles. And because we know, so the DNA markers are also put in the database. Because we know the association between DNA markers and phenotypes from the challenge, we can use the same markers to predict and to check on the profiles of the animals in the selection candidates, in the selection population. And we are looking for the profiles of animals that are surviving. We try to look for the same profiles in the selection candidates. And that information is then used to actually select animals from here. So what will happen? Ultimately, we will start to select animals that have the same profile roughly as the animals that survive and continue to grow well in this population. And this gives us a much more detailed way of selection compared to only using family selection, pedigree, and like I said, only brother, sister, cousin information. No, when you dive more into the detail of the thousands of markers of the DNA, you can get a more accurate selection. So, and does that work? We challenge our animals, I said, in laboratories. We do that under extreme high pressure of pathogens, something that you would not really see in reality. We don't treat the animals at all. We wait until natural fade out of of the disease, of the challenge itself, and we check which animals survive and how they still look. And if you look at different generations that we tested after each other, you see the first generation we started in these tough conditions with an average survival percentage of, say, 20%. So it's really bad. But 2 generations later, after our selection, we already are at, say, 35 to 40%. So it's actually really improving. It almost doubled already. And this continues to do so. So how do we combine all of this into our breeding programs? And this is specifically for the Gona Bay program. So we use this genomic information. We use pedigree-based selection at the same time. We mix it to get the optimal mix in selection, you could say. And we select for PL growth. We select for early growth, late growth. We also select for PL survival and overall survival during grow out. We use information from the field, what we call the sentinel testing in tough environments. We use genomic selection for disease resistance, like I was just explaining. We also look at broodstock hatchery performance to make sure that we're selecting animals for all those traits at the same time, that we get balanced products, animals that do continue to produce, to grow fast, but also survive. So that's a balanced breeding. Why is balanced breeding important? To take care of that. The problem is that we see in breeding is that many traits have a correlation that is not perfect. What does that mean in reality? What we see is if we would be looking at the performance of families in terms of growth on the y-axis, you would see that top families are over here. They're at the high part of the graph. They're growing very well. But if you would look for these animals for their actual disease resistance and challenges, you would see that the performance is actually not so good at all. It's not really, really bad, you could say. We are not at this part of the distribution, but we're average, not really good. So if you would select animals that are purely good for disease resistance, you would say, I would try to select more towards the right side. To this side of the distribution, and there you see that the growth is a little bit lower. So the trick is for structured breeding, balanced breeding, as we call it, to start selecting animals that are a little bit in this part, animals that are actually, surviving pretty well, maybe not the best, but they also grow. And then we get a kind of balanced selection, and that's a better overall result for production, you can imagine. Now, everything in balanced breeding, all those different aspects are combined into, you could say, one product. I'll come back to that a little bit later. And we use genomic selection. All these different combinations are then finally they end up in one PL or one broodstock that we are selling. Now, an important part is and I started off my presentation in this area already, in this part. We create new genetics all the time. It's important to realize for a farmer that having new genetics also means new management. Why is that? Imagine that we are at the current production level, the 100% first generation that I showed in the very first part of my presentation. We are there. Breeding companies try to look for the genetic solutions. They create a new generation, first part that I selected. So you see that the next generation is actually better in terms of potential than the first. So the potential changes, it improves. But that means that, for example, faster growing shrimp will need more feed. It's very simple. I think that makes sense to everybody. That means that the requirements change. That also means automatically, and we should not forget, that also the farm management needs to adjust. Well, first part is putting in more feed, of course, but also looking better at water quality, because water quality will change. Because if you want to fulfill the potential of the new product, you will need to feed them more. That has the consequences. That means that the production level will improve if you do your management well. We have a new production level. That means, again, that we will need a new genetic solution to, within that current production level, again, try to look for better animals. And that will change the potential, and that will change the requirements and the management again. And that will happen generation after generation. So that's crucial to keep in mind. If we change genetics, and we do, that also requires a change in management. You could also look at it from the other side a little bit. We all know shrimp culture globally, but also at national level is super variable. We see very extensive systems, small ponds, for example, little input. And at the very other side, we see intensive farms, high aeration, high quality of feed, more disease control, whereas in the extensive side, there's little disease control. And there's, of course, systems in the middle. The extensive systems will probably require a higher resistant shrimp and maybe can do with a slower growth. Typically, the slower growth is not very important. But the intensive systems, that's the other way around. They need faster growth and maybe lower resistance because they have a better control on the biosecurity in the pond. So they will need a different product. Now, like what I mentioned before, every genetic product that we're producing is continuously improving, but because we are really looking at a different environment, this improvement is still generation after generation happening, but it would be on a genetic line that is more focused on extensive production. And that will be the same for moderate and also for intensive systems. And a solution to make sure that all those different systems can still produce in an optimal way is to provide really genetic lines. Every genetic line is improving every generation on generation after each other, but they are different genetic lines really for different environments or different kind of cultures. So what I've showed in this presentation is first explaining a bit about our company, of course, but also how does breeding work and how can we optimize breeding products for farming, but also the implications of those changes on farming management. Farming management over time, but also for different regions, different areas, or different farming systems. Breeding programs like Hendrix Genetics can offer this genetic improvement over time for different conditions. And by doing so, we hope to improve the shrimp production for our farmers, for our customers in Indonesia and in a global level. Thank you. Terima kasih.
Thank you for your presentation. Please stay with us. Next session is for question and answer session. Please, the speaker to come with me. Baik Bapak dan Ibu yang saya hormati, berikutnya adalah kita ada waktu 30 menit untuk melakukan tanya jawab. Untuk itu saya persilahkan pertama mungkin 3 orang penanya untuk mengajukan pertanyaannya, ditujukan kepada siapa, nanti kita sampaikan. Silakan.
Terima kasih. Tadi saya tertarik pemaparan penggunaan selenium. Pertanyaan pertama, selenium ini apakah termasuk kategori imunostimulan? Memang kalau kita lihat dari spek pakan, itu selenium tidak dimunculkan, Pak. Dan memang kita tidak tahu, baru tahu kalau di sini bahwa di pakan ada selenium. Mungkin kawan-kawan sales pakan ini bisa jawab pertanyaan saya, Pak. Seleniumnya berapa gitu. Kedua, tadi disebutkan peranannya itu kalau nggak salah dengan reaksi akan terbentuk hidrogen peroksida ya, H2O2. Di dalam mungkin di dalam saluran pencernaan ya terjadi reaksi itu. Mungkin saya kalau kembali ke lactobacillus, kalau itu hanya di end reaksinya H2O2, apa bedanya dengan lactobacillus? Lactobacillus biasa kita campur ke pakal dengan harapan itu akan terbentuk H2O2 sebagai desinfektan alami di dalam proses hepatopankreas. Yang ketiga, kalau kita lihat aditif kayak vitamin apalah, kita nggak sebut produknya ya, selalu dimunculkan ada selenium ya, tapi pada konsentrasi 0,000 sekian. Apakah itu berefek? Jadi pertanyaan. Kedua, ada juga produk-produk mineral ya, kalau kita lihat speknya itu dimunculkan selenium. Sebenarnya ini pertanyaan Pak Prof. Edi, peranan selenium di dalam air, apakah berperan di dalam proses molting atau sekedar asal ada selenium gitu ya? Ada beberapa produk mineral, kita lihat ada di situ muncul selenium sekian-sekian persen, terutama mineral. Pertanyaan berikutnya untuk Mr. Sorry, di bahasa Inggris saya boleh potong Pak. Mr. siapa dulu? Mr. Miandrias, about the usage of autopida. In the farmer Indonesia, they already famous the use of autopida. We apply two methods. One method, the continuous running. Yeah, it's mean that 24 hours is running the autopida. And then two methods, they have running only 3 hours after they stopping. I think continue again. So, which the good method for using autopida? Thank you.
Baik, ada pertanyaan berikutnya? Bisa.
Nama saya dari Lampung. Kalau saya ditanya ke I think the presentation is very interesting, especially that as mentioned by our friend here, that the use of automatic feeding that increase the frequency of the feeding to the machine.
Halo, oh ya.
Ya, lebih baik.
Oke. Saya ulangi. To Dr. Hagris, yeah. I think it's very interesting presentation, especially about the auto feeding that you said that by improving or increasing the frequency of the feeding, you can improve the growth of the shrimp. I have some conflicting result on this area, because I also have some experiments on this, that the frequency of feeding, the optimum is like 4 to 5 times, and after that the result is not significantly different statistically in my experience. But other research said that the more frequency that given to the shrimp, that the growth is better. But considering that the shrimps actually is like omnivores, but it's more carnivores, I think, with short gut length, yeah, as opposed to herbivores which has longer gut there. So if we give them the feed frequently, I think the gut is will be full in short time, and the evacuation of gut is also not as also fast. I mean, if you give it the frequency is higher, do you think that this will not, have the effect on the evacuation rate of the gut, or maybe because very short gut maybe is easily satisfied. So giving more frequency of feeding, I don't think that this is a good idea for carnivorous animal. Thank you.
Yeah, it's a very interesting observation you made about the feeding frequency and not seeing the kind of improvement that you might expect by increasing the feeding frequency with automatic feeders. I was reminded about a graphic that I saw from Ross Dodd, who was he owned the company AQ1. These are the feeders that use the sound system, the hydrophone, to detect the feeding behavior of the shrimp. And he compared the gains in growth and feed conversion and production from extensive ponds to intensive to super intensive ponds. The biggest gains were from the more extensive ponds, the bigger ponds. So in other words, the improvement from using automatic feeders in intensive ponds is not that great. And it's for exactly the reason that you say. You can feed more precisely by hand in those small ponds than you can with the big ponds. The one point I would make, however, and this comes from, as I said, I work a lot with shrimp farmers in Ecuador. Their context is big ponds. And if you look at the patterns of feeding by the shrimp, there's almost always a big increase in feed consumption right when the sun goes down, right at sunset and into the early evening. So if you're not feeding at that time when the shrimp want to eat, you're losing out on some potential advantages of doing that. So I think that's one of the advantages of feeding with automatic feeders, is that you can spread out that feed. And I agree with you about the gut retention time of the feed. Normally it's on the order of 40 minutes to 60 minutes, depending on temperature. So the feed is moving through very quickly. So that's another reason to increase feeding frequency, is to spread that out. And you're really not going to change that by adjusting feeding frequency. The feed's just going to pass through. And in fact, the feed is probably consumed multiple times. So it's excreted, and that waste is consumed by other shrimp, so it's probably recycled several times before it's ultimately removed from, with waste discharge or water exchange, something like that. So good comment, though.
Okay, thank you. Next, Pak Agus.
Terima kasih, Pak. Mungkin saya akan bahas dulu mengenai tadi imunostimulan. Apa imunostimulan? Imunostimulan atau zat atau senyawa yang dapat meningkatkan non-spesifik imun sistem di dalam tubuh. Nah, kalau kita lihat dari selenium tadi, selenium itu datanya menunjukkan meningkatkan imun humoral maupun selular. Jadi selenium itu bagian dari imunostimulan. Kalau kita definisikan dia sebagai imunostimulan, tapi pada dasarnya selenium itu adalah suatu mikromineral yang memang jumlahnya sedikit, tapi keberadaannya sangat esensial. Kemudian yang kedua, apakah sama dengan Lactobacillus? Ini saya agak confused pertanyaannya, karena tadi dikatakan Lactobacillus menghasilkan hidrogen peroksida di dalam tubuh yang dapat mengamankan hepato, Pak ya.
Halo. Ya, jadi di beberapa literatur menyebutkan bahwa Lactobacillus itu memang suatu bakteri, Pak. Kalau masuk dalam pencernaan udang, itu terjadi proses mengeluarkan enzim H2, bukan enzim ya, H2O2 dalam jumlah kecil, tetapi itu akan membunuh secara alami vibrio yang ada di dalam udang, di dalam hepatonya, bukan lingkungan luar. Maksudnya gitu, Pak, pengguna Lactobacillus.
Baik Pak, mungkin saya bisa di-sharing Pak itunya, literaturnya, karena menurut saya hidrogen peroksida ini adalah suatu senyawa yang sangat reaktif dan dia harus segera dinetralisir di dalam tubuh.
Halo, ya. Bapak coba buka di Mbak Google, klik Lactobacillus, nanti diterangkan di situ, Pak.
Iya Pak.
Oke, itu
mungkin saya
aja, Pak. Ya. Dan saya bertanya seorang pakar Jepang, dia sebutkan reaksinya seperti itu, Pak. Bahwa pengguna, kalau di manusia kan ada Pak ya, pemakaian Lactobacillus. Saya nggak tahu proses apa yang terjadi di pencernaan manusia. Kalau di literatur disebutkan seperti itu, Pak.
Ya mungkin terima kasih Pak informasi. Tapi kalau dia menghasilkan itu berarti saya tidak tahu, saya tidak bisa jawab. Mungkin saya juga mesti konfirmasi kembali. Tapi kalau kita lihat definisi reaktif oksigen spesies itu tiga senyawa. Pertama O2-, kedua H2O2, yang ketiga adalah OH-. Nah ini hasil daripada metabolisme oksidatif. Jika ini terjadi, seperti saya ceritakan tadi, dia harus segera dihidrolis H2O2 oleh sodium oxide dismutase untuk menjadi H2 dan oleh glutathione peroksidase menjadi H2O dan O2. Nah mungkin kalau H2O2 ini memberi manfaat buat apa dalam suatu literatur. Terima kasih Pak infonya, nanti saya coba cross check lagi. Yang ketiga dosis selenium, tadi Bapak tanyakan juga. Ini dosis selenium ini sangat depending sekali Pak, sangat range. Kalau kita lihat dari beberapa literatur dari 0,5 sampai dengan 2,5 ppm, miligram per kilogram. Jadi sangat kecil sekali.
Itu dijual bebas atau mereknya apa Pak?
Ya.
Bisa dibeli di mana itu, di produk ini apa?
Saya pikir
bebas atau?
Saya pikir itu banyak sekali produk-produk selenium yang bisa Bapak temukan di pasaran. Atau juga saya yakin di mana di setiap feed mill juga sudah pasti. Saya yakin semua pada tahu peran selenium dan setiap feed mill pasti sudah memasukkan selenium ke dalam formulationnya, ya, sehingga itu menjadi salah satu suatu mikronutrien yang harus available. Nah, terkait dengan jenisnya ini sangat menentukan sekali bioavailability dari selenium. Itulah yang sangat menjadi penentu antara dosis dan bioavailability. Itu menjadi suatu indikator ya, yang apakah selenium itu dapat terpenuhi dalam konteks saat dia tercekam atau tidak. Nah mungkin kalau tadi Bapak tanyakan apa produknya, saya pikir bisa di search Pak, banyak sekali produk-produk selenium kalau memang di pakan yang ada itu masih dirasakan kurang dosisnya. Terima kasih.
Oke, jelas saya kira ya. Kita masih punya waktu 14 menit untuk tanya jawab.
Penggunaan autofeeder tadi, Mr. Sahabat tadi. Itu.
What was the question autofeeder?
Okay. 24 hours timing.
He will know that. 24
Hello? Yeah, so I think if I understood the question correctly about the auto feeders, about whether you run it 24 hours or stop it for 3 hours, is that the question? You know, again, I'm going to refer to my experience working with the shrimp farmers in Ecuador who use these, again, in the context of big ponds. What you see again is this peak in feeding activity after the sun goes down and into the early evening. And what tends to happen is that water quality, specifically dissolved oxygen, will go down. And around midnight, the water quality gets to the point where if you continue to feed, the shrimp will not convert the feed efficiently. So as long as your oxygen is always good, in theory, they should eat throughout the night. I think the natural tendency is for the shrimp to eat in the early evening, and then after midnight, they just will eat less, and then they'll begin to eat again in the morning. So, you know, my recommendation would just be to stop the feeding from midnight until early morning. But theoretically, if you're maintaining good oxygen, you should be able to continue to feed 24 hours.
Okay, thank you. Next question, we have still 10 minutes. Pak Pamudi silakan.
Saya Aryo dari Pekalongan. Saya mau nanya aja untuk yang penasaran tadi selenium itu ada referensi nggak untuk batas maksimalnya itu berapa dan efeknya kalau misalnya kadang-kadang dosisnya kan kita nggak tahu ya berapa. Kalau misalnya kita terlalu lebih itu ada efeknya nggak di udang gitu. Ya udah itu aja. Terima kasih.
Baik Pak Rio, terima kasih. Jadi kalau terkait selenium ini adalah suatu zat yang sangat sedikit sekali dibutuhkan. Nah, kita lihat kalau dia sumbernya yang anorganik seperti sodium selenate, itu dosisnya melenceng dikit saja, itu sebabnya akan fatal. Banyak publikasi menunjukkan seperti itu. Nah, kalau tapi dia dalam bentuk selenium organik, entah itu peptide, apa itu yeast, nah itu dosisnya terlebih pun itu tidak berakibat fatal. Yang kedua adalah berapa range dosis? Range dosis selenium kalau ada dua hal ya kita di sini. Kalau kita lihat di meta analisis itulah semua publikasi selenium itu dikumpulkan, kemudian dianalisa, itu spesies depending. Jadi sangat tergantung dari spesies. Nah, udang, ikan, mungkin krustasian lainnya itu dia memiliki range dosis yang berbeda. Tapi kalau di sini kita berbicara udang, range-nya itu kalau kita berbicara yang organik, kalau dari data yang kita lihat tadi, itu sekitar 2 ppm sampai 4 ppm. Tapi kalau kita berbicara ini kita pakai sodium selenate 2 ppm itu akan berakibat toksit. Nah, kalau kita pakai sodium selenate itu biasanya 0,2-0,4 ppm itu oke, requirement terpenuhi. Tapi begitu dia dapat cekaman, sebenarnya kebutuhan selenium ini meningkat. Jadi dia depending sekali condition. Pada saat normal tidak ada cekaman, dengan ada cekaman itu kebutuhannya berbeda. Terima kasih Pak, itu bisa selesai.
Baik, yang penting jangan salah pilih jenis seleniumnya ya. Baik, berikutnya Pak Pambudi.
Terima kasih Prof. Dedi. Saya punya satu pertanyaan buat masing-masing pembicara. Pertama Prof. Kikit dulu deh. Saya ingin melanjutkan pertanyaan tadi sebetulnya. Dari 2 sampai 4 ppm tadi, yang paling optimum secara ekonomi dari misalnya harga pakan dan juga performance di tambak, itu ada nggak nilai fix misalnya sekian ppm buat patokan misalnya buat teman-teman dari feed mill? One question for me, Andreas. I know that extruded feed has better performance in terms of durability compared to pelleting machine. Is there any specific ingredient that can make durability better or worse? The second question is, does single screw or twin screw makes the difference in terms of durability of shrimp feed? One question for John. I know that you show that about nursery systems in Ecuador, and it improves the number of cycles, productivity, etc. Can you elaborate more in terms of what PL stock in the nursery system, how many days before transfer to grow out ponds, what they feed, etc., etc. I think farmers want to hear about that more. Itu aja Prof. Dedi, terima kasih.
Baik, terima kasih. Pak Agus, yang pertama.
Oke, terima kasih Pak Mudi atas pertanyaannya. Optimum dose level atau kita lihat least cost level untuk selenium berapa sih? Nah, kalau pertanyaan itu jawabannya bercabang Pak, bisa. Karena kalau kita least cost, kalau kita bicara dosis, ya itu tidak akan robah. Minimum dia di 1,5 2 ppm itu harus available di situ. In form organic. Kalau kita tanya berapa sih yang costnya, itu tergantung source seleniumnya, tergantung harganya, sehingga begitu harganya makin tinggi dia makin nggak atraktif ntar. Tapi kalau kita ganti batas minimum, pasti itu akan pushing formulation naik harganya. Nah itu tergantung, itu adalah pilihan. Tapi kalau kita bicara dosis, itu single dose ya. Dari data yang ada sekarang at least 2 ppm organik. Nah pertanyaannya tadi sangat menarik, kalau kita kok sudah dikasih organik juga nggak kerja. Nah ini itu juga pertanyaan yang memang terkait dengan bagaimana prosesnya. Karena kalau berbicara organik, diekspos pada suhu tinggi, apakah masih seperti itu? Nah itu juga pertanyaan sebenarnya. Jadi ini sebenarnya yang harus dijelaskan lebih clear gitu. Kalau kita bicara organik, begitu diekspos pada extruder atau let's say stream feed ya, kita ekspos pada suhu di atas berapa, 90-95, apakah dia masih bagus formnya? Nah itu mungkin yang perlu juga jadi pertanyaan yang perlu dijawab dalam suatu kajian gitu. Jadi kita ekspos beberapa suhu, nah apakah dia masih perform seperti itu dengan dosis yang sama? Kan ini benar, kalau kita kelebihan dosisnya itu sangat nggak bagus efeknya. Terima kasih.
The ingredients which make the pellet durable in the extrusion process is mostly the starch. In the extruders, we cook the starch and we gelatinize it, and the cook level go above 90%. What does need to cook the starch, gelatinize the starch, is the temperature, moisture, and retention time. Therefore, extruder provide all these three conditions to starch, so it's fully cooked. Therefore, most of the times when you compare a pelleting versus extrusion cook level, in the pellet system, the starch will be cooked around 50 to 60% only, whereas in the extrusion process, the starch is cooked 90 or above 90%. Therefore, once you cook the starch properly, it becomes a glue, and it is work as a binder. Therefore, that's the reason in the extrusion process we do not use any binder. That's the saving comes in with the extrusion process as compared to pelleting. In pelleting, you use mostly the binders, whereas in extruders, just the starch will act as a binder. You fully cook it. Second part of the question was about single versus twin. As a rule of thumb, industry does not recommend, if you want to make it less than 1.5 millimeter, to use a single screw extruders. It's not easy to operate. Any pellet size less than 1.5, it is recommended to use a twin screw to give you much better consistency day in and day out, same size of the pellet. Single will not handle that lower than 1.5. There are some companies, I know that they are making it 1.2 millimeter with a single, but they're struggling it. You get more consistent, more quality product. Anything less than 1.5 is recommended to use twin screw extruders, and you get much better quality.
Okay.
Yeah, so your question was about the nursery pond systems. You know, looking in Latin America, it's been kind of an interesting history over the last 10 years or so with those systems. A lot of them started out really as acclimation systems, so they would receive the PLs from the hatchery, they would put them basically in a tank and absorb any losses that occurred coming from the hatchery to the farm. So you knew exactly what you were stocking, and the shrimp were held in those systems for no more than 10 days. And that has since evolved into more of a pond-based system. And with those systems, you're stocking somewhere between 300 and 500 per square meter, and you're growing them for 20 or 30 days to get an animal somewhere in the range of 0.5 gram to 1 gram, which is then stocked into grow out. So again, there's a lot of variation in the kinds of systems that are used. In Asia, they tend to be more tank-based systems, and it really kind of depends on the objective, meaning the size at which you want to do the transfer, and that will then determine the stocking density. For example, in the round tank systems in Vietnam, you know, they can be stocked anywhere from 1 to 2 up to 3 to 5 per liter. And then the stock is split after a period of time, and you can either then stock it into grow out, or you can grow it up to a larger animal, as much as 5 grams before stocking in grow out. So there's a lot of variation, really. And I think was there another part of that question? The feeds, yeah. I wish I can remember. Maybe you can tell me what is the smallest extruded feed that's made, because those are being used in nursery tanks. 600 microns. Yeah. So those small extruded feeds are being used in those nursery systems. In the ones in Ecuador, it's kind of interesting because you can very quickly reach a point where the feeding rate can compromise water quality, and then you get into real trouble with survival. So, if you're trying to feed according to body weight, you can then very quickly get to a point where you're exceeding the loading limits to the pond. So some farmers have not paid close enough attention to that. Obviously, having sufficient aeration is key. But yeah, the smallest extruded feeds are being used in those nursery contexts.
Okay, thank you. Bapak dan Ibu yang saya hormati, waktu juga yang telah membatasi kita di dalam sesi kedua seminar dari SIM Treated ini. So we are very grateful for the nice presentation presented by Dr. John Hagrid, thank you. Dr. Miandrias, Professor Agus Suprayudi, and Mr. Robert Blanc. So then please give them applause. Saya akhiri sampai di sini. Mohon maaf apabila ada banyak kekurangan. Dan saya akhiri dengan wabillahi taufik wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you so much for this very special seminar. Ladies and gentlemen, please give a big applause. Dan hadirin berbahagia, kalau untuk acara selanjutnya kami mohon untuk berkenan berfoto terlebih dahulu. Kami persilahkan, terima kasih untuk moderator yang luar biasa, yaitu Profesor Dedi Jusadi dari IPB University. Selanjutnya kami ucapkan terima kasih kepada Dr. John Hargreaves selaku Editor-in-Chief Was Magazine. Thank you to Dr. Mian Rias from Texas E&M University and also Profesor Agus Suprayudi dari IPB University. Dan hadirin berbahagia, pada kesempatan kali ini terima kasih banyak untuk narasumber luar biasa dan juga moderator teristimewa. Terima kasih di kesempatan kali ini untuk seminar di sesi kedua, dan pastinya terima kasih juga apresiasinya dari rekan-rekan yang berbahagia. Dan saat ini kita abadikan momen bersama dengan para narasumber dan juga bersama dengan moderator. Terima kasih. Baik. Thank you, terima kasih banyak. Boleh berikan senyuman, smile, and also big applause to our special guest and also moderator. Sekali lagi beri tepuk tangan paling hangat. Terima kasih Bapak Dedi Jusadi dari IPB University yang sudah memandu acara pada kesempatan kali ini, dan tentunya pada hari yang berbahagia. Kami mohon kesediaannya untuk berkenan melanjutkan acara pada kesempatan kali ini kepada Bapak Denny Mulyono untuk berkenan memberikan sepatah dua patah kata Bapak, karena setelah ini akan ada spesial dari KKP pada kesempatan hari yang berbahagia. Hadirin yang berbahagia, berikan tepuk tangan paling hangat untuk Bapak Denny Mulyono.
Cek.
Waktu dan tempat kami serahkan.
Lebih hangat ya. Bapak Ibu, selamat sore tanpa mengurangi rasa hormat, dan juga pasti sudah mau buru-buru mau kemana mungkin sore hari. Tetapi izinkan saya tadi sebetulnya akan ada deep talk, tetapi ada satu dari halangan dengan kegiatan di pusat ya. Pak Dirjen tidak bisa hadir. Tetapi ada hal yang disangkutkan sebuah pembudidaya mengenai CBIB, cara budidaya ikan yang baik. Dan Bapak Ibu, KKP ada bikin booth di depan dan juga punya dana tahun ini untuk 7.500 sertifikasi CBIB. Untuk lebih jelasnya, ada satu rekan KKP dari Direktorat Produce, Mas Habib. Monggo Mas, waktunya dipersilakan untuk menjelaskan sedikit banyak mengenai CBIB dan programnya, dan setelah itu silakan Bapak Ibu pembudidaya segera atau teman-teman pakan segera ke boothnya KKP, tahu lebih banyak untuk membantu petambak yang tidak hadir hari ini. Waktu dan tempat saya persilakan, tolong kasih tepuk tangan yang hangat untuk Mas Habib. Thank you. Silakan Mas.
Baik, terima kasih. Pertama-tama mohon izin Pak Direktur, saya izin menyampaikan. Perkenalkan Bapak Ibu, nama saya Ajrun Habib dari Direktorat Produksi dan Usaha Budidaya. Saya di sini tadi Pak Direktur Pak Ujang meminta untuk menyampaikan tentang sertifikasi cara budidaya ikan yang baik. Mungkin saya akan sampaikan nggak lama Bapak Ibu, mungkin 5-10 menit. Baik, next Mas. Next lagi. Nah Bapak Ibu, jadi sebenarnya di KKP itu kita punya yang namanya SJM KHP, Sistem Jaminan Mutu dan Keamanan Hasil Pangan. Di situ ada beberapa sertifikasi yang kita lakukan, diantaranya CPIB, cara pembenihan ikan yang baik, ada CBIB, cara budidaya ikan yang baik, lalu ada CPPIB, pembuatan pakan ikan yang baik, CDOB, cara distribusi obat ikan yang baik. Nah, masing-masing sertifikasi ini memang setelah ada UUCK, itu sudah menjadi kewajiban bagi pelaku usaha untuk memenuhi masing-masing sertifikasi tersebut tergantung dari jenis usaha yang Bapak Ibu lakukan. Baik, selanjutnya Mas Idam. Nah kalau di CBIB sendiri itu ada 4 aspek utama jika Bapak Ibu mau mengajukan sertifikasi, karena ini kebanyakan mungkin Bapak Ibu pengusaha tambak udang ya, jadi ada 4 aspek di sini. Yang pertama ada food safety atau keamanan pangan, yang kedua animal health and welfare, kesehatan dan kesejahteraan ikan, yang ketiga environment responsibility, rahmat lingkungan, yang keempat socio-economic aspek atau sosial ekonomi. Nah 4 ini nanti kalau dari CBIB sendiri kita punya checklist, dan checklist itu memang harus dinilai kesesuaiannya dengan unit usaha yang Bapak Ibu jalankan. Next, Mas Idam. Ini dasar-dasarnya, ada permen peraturan menteri, dan Kepmen keputusan menteri Kelautan Perikanan. Ada juga undang-undang dan peraturan pemerintah. Nah ini dari sinilah kita buat checklist cara budidaya ikan yang baik untuk menilai kesesuaian apakah unit usaha Bapak Ibu sekalian layak untuk dilakukan sertifikasi atau tidak. Next, Mas Idam. Nah ini penggolongannya. Jadi peraturannya kalau unit usaha Bapak Ibu ukurannya mikro kecil dari segi modal usaha tanpa tanah dan bangunan ya. Kalau dari modal usahanya sampai dengan 1 miliar itu masih masuk mikro. Kalau mikro itu Bapak Ibu hanya perlu mengurus yang namanya SP4, Surat Pernyataan Penerapan Prinsip-Prinsip CBIB. Lalu kecil lebih besar dari 1 sampai 5 miliar itu juga masih mengurus yang namanya SP4 CBIB, Surat Pernyataan Penerapan Prinsip-Prinsip CBIB. Nah, ketika Bapak Ibu modalnya lebih besar dari 5 sampai 10 dan lebih besar dari 10 miliar, maka Bapak Ibu unit usahanya harus mengajukan sertifikasi CBIB. Nah, ini dua-duanya Bapak Ibu sampai dengan saat ini gratis. Jadi mumpung masih gratis dan juga sudah menjadi kewajiban bagi pelaku usaha juga untuk mengurus SP4 dan sertifikasi ini, maka Bapak Ibu bisa mengajukan sertifikasi dan SP4 itu. Kami di depan juga ada booth, kalau Bapak mau konsultasi, Bapak Ibu mau konsultasi terkait penerbitan ini bisa nanti di depan. Next, Mas Idam. Ini sekilas saja tentang CBIB. Jadi kalau SP4 itu dilakukan oleh yang namanya verifikator, nanti verifikator itu melakukan verifikasi lapangan ke unit usaha Bapak. Sementara kalau sertifikasi CBIB dilakukan oleh auditor yang melakukan audit ke unit usaha Bapak. Nanti outputnya kalau SP4 itu adalah surat penerapan prinsip-prinsip, dan kalau sertifikasi CBIB outputnya sertifikat CBIB. Baik, next Mas Idam. Ini kurang lebih alurnya seperti ini. Intinya kalau disederhanakan dari alur ini, pengajuan CBIB itu ada 2 Bapak Ibu. Bapak Ibu bisa melakukannya melalui OSS, nanti di situ ada pilihan PB-UMKU namanya, perizinan berusaha untuk menunjang kegiatan usaha. Lalu yang kedua, Bapak Ibu juga bisa mengajukan sertifikasi CBIB melalui Dinas Provinsi, Dinas Kelautan dan Perikanan Provinsi di tempat Bapak Ibu berusaha. Jadi bisa dari 2 sistem itu. Kalau untuk SP4 itu mengajukannya ada di sistem informasi kami, Bapak Ibu bisa search cbib.kkp.go.id. Nanti di situ Bapak Ibu bisa langsung mendaftarkan, membuat akun, dan memohonkan permohonan SP4 CBIB untuk yang mikro kecil. Tapi jika unit usaha Bapak Ibu walaupun dia mikro kecil tapi orientasinya ekspor, biasanya buyer akan meminta sertifikat CBIB. Bapak Ibu juga bisa mengajukan sertifikat CBIB tersebut. Lanjut, Mas Idam. Lalu ada sedikit yang mau saya sampaikan di Permen 4 2001. Jadi untuk tambak udang dia dari peraturan Menteri Lingkungan Hidup dan Kehutanan diwajibkan mengurus izin lingkungan tergantung dari luas lahan unit usaha Bapak Ibu. Kalau misalnya dia bisa dibuka. Jadi ada SPPL, surat pernyataan pemenuhan prinsip lingkungan hidup, ada UKL, UPL, upaya pemantauan lingkungan hidup dan upaya kesesuaian lingkungan hidup, yang terakhir ada AMDAL, analisis dampak lingkungan. Ini itu 3 hal ini sebagai persyaratan dasar jika Bapak Ibu mengajukan sertifikasi CBIB. Jadi 3 hal ini harus dipenuhi terlebih dahulu. Nah, ini untuk udang sendiri, ini Peraturan Menteri Lingkungan Hidup dan Kehutanan nomor 4 tahun 2021, Bapak Ibu. Jadi di sini digolongkan melalui luasan untuk pengurusan izin lingkungan. Nah, di SPPL itu dia sampai dengan kurang lebih 10 hektar unit usaha budidayanya. Lalu kalau UKL UPL itu dari 500 sampai 10 hektar. Di atas 500 hektar sudah harus mengurus AMDAL. Nah, ini sebagai persyaratan juga. SPPL itu hanya surat self-declare, jadi saya menyatakan bahwa saya memenuhi prinsip-prinsip lingkungan hidup, nah itu SPPL yang sampai dengan 10 hektar. Sisanya UKL, UPL, dan AMDAL Bapak Ibu harus urus ke Dinas Lingkungan Hidup di Provinsi Bapak Ibu berusaha. Lalu selanjutnya SNI, Dam. Lalu terkait dengan lingkungan Bapak Ibu, karena kita tahu tambak udang menghasilkan limbah, jadi kita ada yang namanya SNI IPAL, Standar Nasional Indonesia terkait instalasi pengolahan air limbah. Nah, Bapak Ibu ketika mengajukan sertifikasi, karena salah satu aspek CBIB tadi adalah aspek lingkungan, maka Bapak Ibu harus paling enggak bisa menjadikan SNI ini sebagai acuan Bapak Ibu untuk berusaha atau ketika Bapak Ibu akan mengajukan sertifikat CBIB. Nah, di ininya, Dam, yang kualitas airnya. Ini juga Bapak Ibu bisa download di Google, bisa search di Google SNI IPAL. Nah, ini paling enggak ketika teknologi tambak udang Bapak Ibu sudah masuk intensif atau semi intensif, paling enggak kami akan minta data kualitas air di IPAL Bapak Ibu. Ketika air buangannya ada TSS, ada pH, BOD, amonia, dan vibrio. Nah, paling enggak TSS dan BOD-nya harus di bawah 80 dan 20. Jadi kurang lebih itu Bapak Ibu yang bisa saya sampaikan terkait CBIB. Mungkin kalau ada pertanyaan atau Bapak Ibu mau dibantu untuk syarat-syaratnya apa aja, nanti bisa ke booth kami di depan. Mungkin cukup sekian. Terima kasih Bapak Ibu. Selamat sore.
Oke, baik, terima kasih. Di kesempatan kali ini ada Bapak Ibu yang ingin mengajukan sesi tanya jawab. Kami buka. Silakan Bapak atau Ibu. Sepertinya sudah jelas ya. Baik, sekali lagi boleh beri tepuk tangan paling hangat untuk Bapak Habib dengan bagaimana cara pengajuan CBIB. Terima kasih Bapak atas arahannya di kesempatan kali ini, dan pastinya hadirin berbahagia, tentunya di kesempatan kali ini untuk acara selanjutnya adalah closing statement yang langsung akan disampaikan oleh Bapak Denny. Kembali kami mengundang dengan hormat kepada Bapak Denny untuk berkenan menyampaikan closing statement di kesempatan kali ini. Hadirin yang berbahagia, berikan tepuk tangan paling hangat
Selamat sore Bapak Ibu, terima kasih untuk waktu yang disempatkan sampai, terutama bagi teman-teman yang masih bertahan di ruangan ini sampai sore hari ini. Saya harap apa yang kita dengar selama 1 harian ini dari beberapa speakers mengenai market dari sesi pertama, lalu setelah itu sesi kedua mengenai budidaya, carrying capacity, ataupun juga lain-lainnya, berharap dapat memperkaya kita semua, mendapatkan sesuatu. Dan inilah akhir dari sesi dari hari ini. Dan Bapak Ibu, untuk besok hari, sebagaimana panitia sudah pernah mengkonfirmasikan, besok hari kedua kita akan ada breakout room, tidak di sini lagi tapi di lantai 3. Sesuai dengan ada Palmer's Day, ada production, ada juga satu lagi adalah untuk market. Jadi jangan lupa besok acara dimulai sesuai dengan tadi ada schedule-nya, rundown-nya di lantai 3 di hotel ini juga. Demikian dari saya, terima kasih untuk waktunya. Wassalamualaikum warahmatullahi wabarakatuh. Selamat sore, salam sejahtera bagi kita semua. Saya kembali kepada MC.
Terima kasih banyak, berikan tepuk tangan untuk Bapak Denny Mulyono. Baik Bapak Ibu hadirin berbahagia, tentunya demikianlah untuk acara kita pada kesempatan kali ini. Namun sebelumnya Adinda mengingatkan kembali bahwa keesokan hari kita akan bagi sesi acara kita dengan break room yang berada di lantai 3. Dan acara akan dimulai pada pukul 8.30. Kami harapkan kepada rekan-rekan yang berbahagia bisa hadir tepat waktu. Dan tentunya di kesempatan kali ini juga kami mengucapkan terima kasih untuk moderator dan juga narasumber yang teristimewa. Once again, kita juga mengucapkan thank you for our sponsor, US Soybean Export Council atau USSEC. Boleh beri tepuk tangannya? Beri tepuk tangan untuk Kansas Soybean Commission, PT Delos Teknologi Maritim Jaya, PT Suritani Pemuka, PT Konabai Indonesia, PT Centralpertiwi Prima, thank you, PT Centralpertiwi Bahari. Terima kasih untuk PT Matahari Sakti, terima kasih untuk Vistek, PT Gold Coin Specialties, terima kasih untuk TROBOS Aqua, dan tentunya bersama dengan Agristream TV. Dan di kesempatan kali ini hadirin yang berbahagia, sekali lagi boleh beri tepuk tangan aplaus paling luar biasa untuk kita. Dan saatnya saya Adinda Davi undur diri, saya akan tutup dengan pantun. Buah duku, buah semangka. Adinda Davi pamit dulu, sampai jumpa. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore.